Welcome back to yet another really exciting section, where we will finally connect a MongoDB database with our application. And to do so, we're going to use the very popular Mongoose library, which makes working with MongoDB in Node.js really easy. So in this section, we're going to take a deep dive into the Mongoose library and really make our application and API come to life with real data coming from a real database. So we're going to talk about data models, implement important API features, add some data validation, and also use the advanced MongoDB aggregation pipeline. So get ready now for a ton of great content coming up. Hello and welcome back. So now it's finally time to connect the MongoDB database that we created with our Express application. And the first step in doing that is to actually get our connection string from Atlas. So just like we did before, when we connected the database to Compass and to the Mongo shell, we need to get our connection string in order to connect the application to this hosted database. Now, in case you're not using the hosted database on Atlas, then I will also show you how to connect your local database with the application a bit later in this video. Alright? Anyway, just click here on Connect Your Application, and then this here is our connection string. Just make sure that you select Node.js here actually, because the string might change based on that. Now we also need the version, and of course it's later than 3. And so let's now go ahead and copy our connection string, and then back in our application, we create it as an environment variable here in our config file. So I already have database password. Let's create database now, and then put our string in here. Now, two things about this connection string. First, here in this place, we need to put in our password. Now we could go ahead and copy the password from here and then paste it here, but I prefer to leave it in a separate variable and then replace it in code. Okay, I will just actually change this password here to an uppercase password, okay? So password to make it a bit more visible. Then second, this here is actually our host, so basically the place where the database is hosted, and then /test. Okay, now this test here is the name of the database that we want to connect to. And in our case, we already created the Naters database, right? So let's check that out actually here back in Compass. And if we go here to collections, then we see that here we already have our Naters database. So we did that by the end of the last section, remember? And so it's very important that here in this connection string, we replace this test with the name of our database. So Naters, okay? So very important here, again, do not forget to put this here, otherwise it's not going to work, alright? Now in case you're using the local database, like I just mentioned before, this connection string is a lot easier. So let's just create a variable for that one as well, database local. But again, if you're using this database string here, you don't need to worry about this part, okay? I'm just doing this in case that you are using the local one. And so in this case, it's quite simple. It's just MongoDB. And this is kind of a protocol here. So instead of HTTP, Mongo uses these like MongoDB protocol or something. Then localhost, and then the port, which we already talked about a couple of times, and it's 27017. Right? Remember that? And then just like before, we also need to specify the name of the database, which should be Naters, right? Now, in order for this to work, of course, you need to keep your MongoDB server, so that MongoDB process running at all times. So switching here to the terminal, so this local process here is the one that I mean, okay? So never close this process, so this terminal window, when you're working with your local database. Okay, so otherwise it's not going to work. Okay, and that's it for configuration. Next up, we need to install a MongoDB driver. So basically a software that allows our node code to access and interact with a MongoDB database. And there are a couple of different MongoDB drivers, but we're going to use the one that I would say is the most popular one, which is called Mongoose, which adds a couple of features to the more native MongoDB driver. Okay, but don't worry, in the next lecture you're actually going to learn all about Mongoose and why we're using it. Okay, for now let's just go ahead and install it. So Mongoose, and the version that I'm going to use is version 5, and so please go ahead and install version 5 as well, so that we're on the same page with our code here. Okay, so by the time you're watching this video, Mongoose 6 or even 7 maybe might already be out there, and then something might have changed and then your code might not work the exact same way. Okay, so please just install version 5, because that's actually a pretty stable version at this point, and I don't think that they are gonna add much important features in the future. Alright, so in our package.json, it should now be here, so 5.5.2, yours is probably a bit later, but that should not be a problem. Okay, let's go now to server.js here, which remember is kind of the file where we do all of the setup of our application. For example, the environment variables, or we import or express application, and we also start the server down here. And so this is also the file where we're going to configure MongoDB. So let's start by requiring our Mongoose package here. All right. And so now we have access to the Mongoose variable, and on there we simply call the connect method. All right. Now into this connect method, we need to, of course, pass in our database connection string, right? But remember that in there we still have the password. So basically this password placeholder here. And so before we pass in the string, we need to actually replace it. So replace it with the real password that we have here. All right. So let's quickly do that. And I'm simply going to call this variable db for database. And so let's get our process.env.database. So that is, of course, our variable where the string here is stored, right? So we're getting that, and then replace. And we want to replace password. Now this here comes from the HTML close tag package that I have on my VS Code. All right, so process.env.database password. Give it a save. And okay, so that makes sense, right? So we're simply replacing this placeholder string with our real password in this connection string. Okay, and so now we can use this variable in our mongoose.connect. So in here, the first argument is actually that connection string, so db, and then second, we pass in an object with some options, okay? And these are just some options that we need to specify in order to deal with some deprecation warnings, okay? So don't worry too much about these ones. So use new URL parser, set it to true. Then we need to use create index, also set to true, and then use find and modify and set it to false. All right. So again, these here are just some options to deal with some deprecation warnings. And so when you're creating your own applications, just go ahead and use just exactly the same. All right. Now this connect method here is going to return a promise. And so let's actually handle that promise by using then. And this promise here actually gets access to a connection object. So let's simply call it con here for connection. Okay, so basically this connection will be the resolved value of the promise. And so just to show you that we're actually connected, I want to just log this object to the console. So console.log connection. And actually I want to see the connections property on there. Okay, and we can also log to the console something like db connection successful. All right, give it a save here. And then of course it displays these warnings here because of our ESLint, but don't worry about that. That's just the way that we configured it, right? And so let's now go ahead and actually run this application. Now let me remember what kind of scripts we have. So we have start dev and start prod. Now since our script here is not just called start, which is kind of a standard, we always have to type npm run start dev instead of writing just npm start without the run. And so let me go ahead and change the name here back to start, and then we have start for production. Okay, so npm start, the app is running now. And indeed, our database connection was successful. So great. And now here we have our connections object. And as you see, there's a lot of stuff in here. And we can see our username here, the host, the password, of course. And this stuff here doesn't really matter, of course. I just wanted to log it here, just so we see that our connection was actually successful. And so let's get rid of that. And we can actually get rid of all this here as well. So this is just a one-liner here. Oh yeah, just missing this parenthesis. Okay. Now here it's saying me that we declared this variable but never used it. So let's indeed get rid of it. All right. Now just as a final step, let me show you how we could also connect to the local database, again, in case you're using that one. So let's just duplicate this line, comment it out. So this is the hosted database version. And then here we would just have to put in the local one. So that's database local. Let's give it a save. And we're also connected successfully to that one. Okay, so that's just how you would do it in that case. All right, but as I said, in this course, we will actually use the hosted one. So that's the one that I'm keeping here, right? Actually, I'm deleting this one. We don't need it anymore. Now, of course, there could also be problems connecting to the database. For example, the host might be down, or we might have some error in our connection string. And in that case, we should catch that error. But we will leave error handling for a bit later in the course. And so for now, I'm not having any catch method here, just the then method here, assuming that everything works fine. All right. And now finally, I want to actually go ahead and delete the collection that we already created in our database, just so that our Mongoose driver does not interfere with that in any way, so that there's no problem there. And so let's move back to Atlas here, hit on our collections, and then simply delete the collection from here. And now we need to put in here the name of the collection, just so we don't do any mistake here. So drop, and all right, so now we have an empty database here, ready to start filling with our data, starting right in the next couple of videos. So we connected our application with the database using Mongoose in the last lecture. But wait, what actually is Mongoose? Well, Mongoose is an object data modeling library for MongoDB and Node.js, providing a higher level of abstraction. So it's a bit like the relationship between Express and Node. So Express is a layer of abstraction over regular Node, while Mongoose is a layer of abstraction over the regular MongoDB driver. And by the way, an object data modeling library is just a way for us to write JavaScript code that will then interact with a database. So we could just use a regular MongoDB driver to access our database, and it would work just fine. But instead, we use Mongoose because it gives us a lot more functionality out of the box, allowing for faster and simpler development of our applications. So some of the features Mongoose gives us is schemas to model our data and relationship, easy data validation, a simple query API, middleware, and much more. So in Mongoose, a schema is where we model our data, so where we describe the structure of the data, default values, and validation. We then take that schema and create a model out of it. And the model is basically a wrapper around the schema, which allows us to actually interface with the database in order to create, delete, update, and read documents. All right, so this was just a very quick introduction. Now let's actually go ahead and create a simple schema and model. So in the last lecture, we learned about Mongoose schemas and models. And so let's now implement a very simple schema and model for our application. And for now, let's do that right here in our server.js file. Later, of course, we're going to move that into a different file. So Mongoose is all about models. And a model is like a blueprint that we use to create documents. So it's a bit like classes in JavaScript, which we also kind of use as blueprints in order to create objects out of them, right? So again, we create a model in Mongoose in order to create documents using it, and also to query, update, and delete these documents. So basically, to perform each of the CRUD operation, so create, read, update, and delete, we need a Mongoose model. And in order to create a model, we actually need a schema. So we actually create models out of Mongoose schema, just like we learned in the last video. And we use the schema to describe our data, to set default values, to validate the data, and all kinds of stuff like that. So just as you will see right now, because now we're actually going to start creating a very simple schema for our tours. So let's say tour schema is a new mongoose.schema, and then in here we actually pass our schema as an object. All right. We can then also pass in some options into the schema, but I'm leaving that to a future video where we actually need that feature. So remember the tour documents that we used to create in the last section when we started exploring MongoDB. So we always gave them a name, a rating, and a price, right? And so let's now replicate that here by saying name and then describing what type of data we want as the name. And we want it to be a string. So Mongoose actually uses the native JavaScript data types. And so here we can say string, or as the rating, we can say that we want a number, and the same as the price. It should also be a number, right? So this is the most basic way of describing our data. So we have a name, a rating, and a price, and we specified the data type that we expect for each of these fields. So again, this is the most basic way of describing a schema, but we can take it one step further by defining something called schema type options for each field, or only for some specific field. So let's start here with the name, and instead of just specifying it as a string, let's actually pass in another object. And so now we say that we want the type to be string, but we can now define a couple more options. Okay, for example, we can say that this field is required. And so we simply set the required property here to true. All right, so again, this object here are the schema type options, and they can be different for different types. For example, the number type has some different schema options than the string here, but many of them are also similar. So for example, the require, we can use it on number as well. And so let's do that here. So the type, we still want it to be a number, and we also want it to be required. Okay, now here in the required, we can actually specify the error that we want to be displayed when we're missing this field. So in order to do that, we just have to pass in an array, and the first one is true, so the first element is true, and the second one is the error string. So let's say a tour must have a name, and then here let's do the same. A tour must have a price. Okay, then we can also set default values, and let's do that here for the rating. So again, I'm going to specify some schema type options here, which is not mandatory, so it's enough to simply define the type here, like we did, but if we want some more features, then we need to really specify the schema type options object. Okay, and then we need to specify the type again, which is number, and as a default, I want it to be 4.5. And so if we now create a new tour document using the schema and not specifying the rating, it would then automatically be set to 4.5. All right? And just to finish, let's try another one here, which is to say that the name should be unique. So unique, and set it to true. And so like this, we cannot have two tour documents with the same name. All right? So this is our very basic schema. Let's now go ahead and actually create a model out of it. All right? And that's very simple. We simply create a variable called tour, and then mongoose.model, then the name of the model, which is tour with an uppercase T here. All right, and so that's just kind of a convention in programming to always use uppercase on model names and variables. So here it's the same. So I also created this tour variable here with a capital T, just so we know that we're dealing with a model here. All right, so the name of the model and then the schema. And that's it. So just like this, we created a tour out of the schema that we created here in the beginning. All right, and so in the next video, we're gonna then use this model here in order to create our very first tour document. All right, so just to recap here, we used new mongoose.schema here to specify a schema for our data. So basically describing it and also doing some validation. For example, this required here, this is actually something called a validator because it is used to validate our data. In this case, simply to validate if the name is actually there. And there are a lot of validators in Mongoose, and we can actually also create our own. And so, of course, we're going to talk about that a bit later, again, once we actually need these features. Anyway, let's now quickly move on in order to finally start using the model that we just created. Let's now start creating documents, testing the model, and really start using Mongoose. And I'm really excited about this video. So really, let's get started here. So what we're going to do is to create a new variable, and I'm going to call it test tour. And this will be a new document created out of the tour model that we created in our last lecture. So what we're going to do is to say new tour, and then in there pass an object with the data. So name, let's say, again, the forest hiker, just as we've been using before. Then the rating, let's say 4.7. And then the price, let's say 497. Okay? So this is again a new document that we created out of a tour model or function constructors. And so, as I said before, this is kind of using JavaScript function constructors or JavaScript classes if you're using ES6, basically to create new objects out of a class, right? And so that's exactly the same syntax actually. So we use the name keyword and then the class name in ES6, just like this. All right, now here it's not exactly the same, but this analogy is helpful to understand how this works. So this test tour document that we just created is an instance of the tour model. And so now it has a couple of methods on it that we can use in order to interact with the database. So let me show that to you. So we can now say test tour.save. And this will then save it to the tours collection in the database. Okay? And it's really as simple as that. So again, we have our document instance, which is test tour, and on there we can then call the save method in order to save the document to the database. Now this save here will then return a promise that we can then consume. So for now, let's use then for that, and in the future we will actually use async await in order to consume these promises, but for now let's keep it simple and not create any more functions. And so instead, we're just using the then method here. So in here, we get access to the document that was just saved to the database. So basically, the resolved value of the promise that the save method returns is the final document as it is in the database. And so let's now actually go ahead and log that document to the console. All right. Now, on the other hand, saving this document to the database might also go wrong. And so let's catch that error. Okay. So just like before, we use the catch method in order to catch any potential errors. And so if there is an error when saving the document to the database, we will be able to catch that error here in this method. Okay, so basically here in this function that I'm passing into catch. Okay, and for now, all I want to do really is to also log it to the console. Let's say error, add some emoji here to make it more visible in the console, and then we can pass in a second argument into the console.log, which will then be the error. Okay, are you ready? Then let's give it a save now, and that will then execute the code that is in here. So basically create this new tour and try to save it to the database right away. Okay, so let's give it a save now and see what happens in the console. And indeed, here we go. So you see that this is the document that was just saved to our database. All right, so here we actually see the ID as well, and that is simply auto-generated by MongoDB, and it's simply the unique identifier for the document. So just like it happened before in the MongoDB section, we automatically get this unique identifier for the new object. Then Mongoose also automatically adds this v and set it to 0 here, but that's not really important at this point. Okay, what matters here is that our new document was actually successfully added to the database. And just to make sure, let's actually move over to Compass and take a look at our database there. So here we have the tours collection, and then we have the document that we just created. So it has that exact same ID, and of course all the other data that we put in there. And so indeed, this is the object that we just created. And keep in mind that we had actually deleted the tours collection here in one of the previous videos, right? But Mongoose automatically created this new collection here as soon as we created the first document using the tour model. And so this name here basically comes from that tour model. It simply gives us this plural name, just as we had before. Perfect. We just made our Express application really interact with a MongoDB database for the very first time. And that's actually really amazing if you ask me. So this means that right now we are able to create documents right from our code. So that makes me really happy. And so let's actually try it again with another one. All right. But actually before we do that, I want to just reload this file here, which will then try to save this document here to the database again, right? Simply because all this code here is run each time that we save the file. Now let's try to guess what is going to happen as soon as I save this file. Can you guess? Let's wait for it. And indeed, we get something different now. We get an error here. And the error that we see is this duplicate key error collection, which down here says this duplicate key. Okay, so we already have a tour with the name of Forest Hiker, and so now we were trying to create another one, and since in our schema we have this unique property here that is not allowed. Remember that? So we set this unique here to true in order to make it impossible to have two tours with the same name. And so we just proved that this is actually working. All right, so let's simply replace the code that we have here in order to create a new tour with another name. So let's call it the Park Camper. And let's go ahead and remove the price and also the rating. So can you guess what's going to happen now? Let's actually clear, or actually it already loaded it, because as soon as I clicked here, it then saved the file. And so, yeah, we just got another error. So you can see that up here, meaning that we didn't successfully save this document to the database. And what we got here now is a validation error coming from the price field saying a tour must have a price. And so that is exactly the message that we specified up here, right? Simply because in this line we said that the price is a required field. All right, and so this required, as I mentioned, is a validator, and so down here we then got a validation error. And so let's now fix that and specify the price, let's say $9.97, and give it another save. Now this time it should work because the rating is not required. And so when we come down here, our document was actually successfully saved to the database. You see? Now we didn't specify the rating here in this test tour, but you see it's still 4.5. And that is because we set the default to 4.5 up here. So I just wanted to show you that here in this quick example. Okay, so we were successful again. So let's come back here, reload, here clicking this button. And indeed, we now get our 2 tours. Great. And I remember how amazing it felt for me when this worked the first time when I was starting to learn Express and Mongo and how to build these applications. And so I really hope that you're feeling the same way right now as you just created your very first documents using Express and of course MongoDB. Up until this point, we have just written our code without thinking much about our application architecture. It wasn't really important until now, but now that our app is really starting to grow, we need to start worrying about the way that we design our code architecture. And this lecture will just be a brief introduction to backend architecture, starting with the MVC architecture. So in this project, we're going to use a widely used and well-known architecture called the Model View Controller, or MVC for short. And there are different ways of implementing the MVC architecture, some more complex than others, but we're going to implement it in a very straightforward way here. I just wanted to let you know that if you Google around for MVC, you will find it implemented in some different ways, okay? Anyway, in this architecture, the model layer is concerned with everything about the application's data and the business logic. And we're going to learn what business logic means in the next slide. Next up, we have the controller layer, and the function of the controllers is to handle the application's request, interact with models, and send back responses to the client. And all that is called the application logic. Finally, the view layer is necessary if we have a graphical interface in our app, or in other words, if we're building a server-side rendered website, as we talked about before. In this case, the view layer consists basically of the templates used to generate the view, so the website that we're going to send back to the client. And that is the presentation logic. For now, we're just building an API though, so we're not really concerned about views just yet. That's for a bit later in the course. So using a pattern or an architecture like this allows us to write a more modular application, which is going to be way easier to maintain and scale as necessary. And we could take it even further and add more layers of abstraction here. But in this kind of smaller application, the MVC architecture is more than enough for our needs. Now, all this may sound a bit abstract, so let's take a look at MVC in the context of our app and the request-response cycle. So as always, it all starts with a request. That request will hit one of our routers, because remember, we have multiple routers, basically one for each resource, like tours, users, etc. Now the goal of the router is to delegate the request to the correct handler function, which will be in one of the controllers. And again, there will be one controller for each of our resources to keep these different parts of the app nicely separated. Then, depending on the incoming request, the controller might need to interact with one of the models, for example, to retrieve a certain document from the database or to create a new one. Once more, there is one model file for each resource. After getting the data from the model, the controller might then be ready to send back a response to the client, for example, containing that data. Now, in case we want to actually render a website, there is one more step involved. In this case, after getting the data from the model, the controller will then select one of the view templates and inject the data into it. That rendered website will then be sent back as the response. In the view layer, in an Express app, there is usually one view template for each page, like a tour overview page, a tour detail page, or a login page. In the example of our Nader's app, of course. So that is a broad overview of the architecture that we're going to implement in this project. Now to finish, let me just go into a bit more detail on model and controller. So one of the big goals of MVC is to separate business logic from application logic. You will hear about these types of logic all the time when you browse Stack Overflow or some site like that. But what are these types of logic actually? Well, the difference is a bit opinionated, but this is my take on it. So application logic is all the code that is only concerned about the application's implementation, and not the underlying business problem that we're actually trying to solve with the application, like showing and selling tours, managing stock in a supermarket, or organizing a library, for example. So again, application logic is the logic that makes the app actually work. For example, a big part of application logic in Express is all about managing requests and responses. So in a sense, we can also say that application logic is more about technical stuff. Also, if we have views in our app, the application logic serves as a bridge between model and view layers, so that we never mix business logic with presentation logic. Alright? Now, about business logic, it's all the code that actually solves the business problem that we set out to solve. Let's say again that our goal is to show tours to customers and then sell them. And the code that is directly related to the business rules, to how the business works and the business needs, is business logic. Now, if that still sounds a bit too philosophical, some examples in the context of our Nader's app are creating new tours in the app's database, checking if a user's password is correct when he logs in, validating user input data, or ensuring that only users who bought a certain tour can review it. So all this stuff is concerned with the business itself, and so it's part of the business logic. Now, we need to keep in mind that application logic and business logic are almost impossible to completely separate, and so sometimes they will overlap. But we should do our best efforts to keep the application logic in our controllers and business logic in our models. And there is even this philosophy of fat models, thin controllers, which says that we should offload as much logic as possible into the models to keep the controllers as simple and lean as possible. So a fat model will have as much business logic as we can offload to it, and a thin controller will have as little logic as possible, so that the controller is really mostly for managing the application's requests and responses. Okay? So now keep all this in mind as we move on in progress into building our applications. We just learned a lot about MVC, and so let's now very quickly refactor our code in order to fit that architecture a bit better. And actually we already have our controller folder here, and the tour and the user controllers in them, and we already have the routes here in the route folder. And so really what we need to do in this video is to create a model folder and create a tour model in there. So let's do that. So models, and in there the tour model.js. Let's close up these guys. And so let's go ahead and copy, or cut actually, this schema and this entire model declaration here, and put it in the tour model. We will also want the Mongoose importing here. All right. And in fact, let's get completely rid of this code. All right. So this here was just for testing and we don't need it anymore. So it has done its job. And so all we really want to do in this file here is to connect to the database, but everything that is about the models themselves will always live inside of a file inside of the models folder. All right. Now in here, ESLint tells us that this variable here has not been used, but actually we want to use it because we want to export the model from this file. So module.export, and this should actually be the only thing we export from this file. And so we use the kind of default export with module.export. Okay, and so this is our very simple tour model that we created in the last lecture. And now here we put it in its own standalone file and then finally exported it from here. Okay, now where do we actually need this tour? So in other words, where are we actually going to create and query and delete and update tours? Well, we're going to do so in the tour controller, right? So right here. And so let's go ahead and actually import the model in here. So right here at the top, and I'm giving it the exact same name. So still tour. And now I want to require, so the current folder, then up one folder, and then down into the models folder, and in there, tour model. Okay, now of course it's telling me that I'm not using this variable, but don't worry about that for now. So next up, I want to get rid of this place here where we actually import the data as a JSON file. So of course, we no longer need this. This here was just for testing purposes. So let's get rid of it. You can also comment it out if you want to leave it maybe as a reference for yourself. Then just go ahead and comment it out. Then down here we get this error because the variable that we just deleted is of course no longer defined. And so let me comment out this piece of code here, because again we're going to need something similar to this. Okay, get tour. Let's comment all of this here out as well, just so that we don't get any errors as soon as we save this file. Then here actually we can get rid, well, kind of all of this. So we're no longer going to use any of this. So let me just keep this piece here. So I'm going to copy it, delete everything else from this, then put it back here. We still get this error, and so I'm commenting out this piece of code. All right, and here we don't get any errors, so let's just leave it like this for now. Okay, so what I just did here was to basically clean the code that we wrote before in order to no longer depend on the data that we had in the JSON file. All right, so now we should have no more errors, or actually we should in this check ID function. And this check ID function, we in fact no longer will need it. Okay, because from now on, we're going to start working with the IDs that are coming from MongoDB. And Mongo itself will give us an error if we use an invalid ID. So this function that we have here was actually very useful for showing you how middleware actually works by giving you this very practical example here. And later in the course, we will of course use more middleware, but this particular function here, we will no longer need it. So let's get rid of it, and also of this file system import, again, because we're no longer using the file here. So we still got some error here. Let's see what's happening. And it looks like it is in the tour routes. Okay, and so actually that's the one that I was gonna change next. So the problem here is that this tour controller.checkID, of course, no longer exists because we just deleted it. And so let's get rid of this as well. Or actually, let me just comment it out, okay? So that you keep in mind that you can use this .param function here to define parameter middleware in your own applications, okay? So I don't want you to forget that. And so just leave it here in your code so that maybe later when you come back to it, you still know that it's there. Okay, so now I saved it, and so we're back on track here. So everything is back to working, and our code is now sufficiently well refactored so that in the next video we can actually start implementing the CRUD functions in our API. So basically getting all tours, creating tours, deleting tours, and updating tours. So one by one we will start implementing these controller functions, or handler functions if you prefer that, starting in the next video. So you already learned how to create new documents in the database. But in this lecture, I'm going to show you an easier and even better way of doing so as we implement or create tour handler. So at this point, our API basically doesn't do anything anymore. It doesn't work anymore because basically we deleted all the functionality that we had in the last video. And we did so that over the next couple of lectures, we can rebuild it using a real database. Okay, so basically finally building our real API. And we're going to start by implementing the create tour function, which is, remember, the handler function that is called as soon as there is a post request to the tours route. So that's what we have here in tour routes. So let's put that here. So what I just said is this. So we have this check body here, which actually is something that we will be able to delete as well. So where is that actually? Check body. All right. So this is yet another of these functions that we really don't need anymore, because this was basically to validate the body. So to see if it had the name or the priced property in them, right? But now our Mongoose model is actually going to take care of that. And so again, this here was nice to actually show us how middleware works, but now we can get rid of it. Okay, and so I'm going to delete it from here as well. Give it a new save, and it's now back to working. Anyway, the function that we're creating now is this create tour function, which is the one that is going to get called as soon as someone hits the tour route with a post request. Okay, so just to recap that, because I know that it can be a bit confusing with these different files and different folders and different functions, but it's also really important that we start organizing our code right from the beginning. Okay, anyway, we are here in the create tour function, and so let's now actually create a new tour. And we're going to do that based on the data that comes in from the body. Remember that? Now, remember how we used to create documents a couple of lectures ago? So we did it like this. For example, let's say new tour, then equal to new tour, and then the data in there. So we did it like this, and then, or let's say new tour, and then we did new tour dot save. And that works kind of fine, but we can do it in an even easier way. So instead of doing this, we can do tour.create and then pass the data in there. Okay, and that will do the exact same thing. The main difference is that in this version here, we basically call the method directly on the tour, while in this first version, we called the method on the new document. Okay, and so that is completely different. So again, we had the tour that we created from the model. And then on that tour, we used the save method because the document has access to this method and a lot of other methods as well. But here in the second situation, we call this create method right on the model itself. Okay? Now, remember how this save method here returned a promise, right? And so this create here does return a promise as well. And so in order to get access to the final document as it was created in the database, we would then to have use .then. Okay? But instead of using promises like this, I'm going to start using async await. All right? So this function here should be an async function. And so all we need to do is to write async right here. So we have async, and so we can now await the result of this promise here. So I hope you are familiar with this, and I actually have a section in this course that deals with exactly this kind of stuff. So if you didn't watch that section, but are still not 100% familiar with async await, then please go ahead and watch that section so that you really understand what's going on here. Okay? So instead of using this then here, I'm going to use async await and then save the resolved value of this promise in the new tour variable. Okay? Now the final piece of the puzzle here is to, of course, pass some real data into this create method. And so instead of this empty object, we're going to pass in the request body. So rec.body. And so that's the data that comes with the post request, right? Now just one more time, just to make sure that everything is clear to you. Okay, so we can use the tour model directly and call the create method on it. Then into that function, we pass the data that we want to store in the database as a new tour. And that data comes from the post body, right? And so that's stored inside of request.body, so this variable here. Now this method here will then return a promise, and we await that promise using async await, and then store that result into the new tour variable, which will be the newly created document already with the ID and everything. Okay, so I'm going to keep this code here just as a reference. And so now let's get this piece of data here back, piece of code actually, give it a save, and now we get this ESLint error. So let's take a look at that, just put our mouse on here, and it tells us that async functions are not supported until this node 7.6. And so this ESLint error comes from that node plugin that we actually installed. So you can see that here, all right? So what we're going to do to fix this is to simply go to package.json and in here define the node version that we are actually using. So that's very simple. We just need to specify the engines property here in our JSON document and set node to greater or equal than 10. Okay, and that's because in this course we are using at least node 10. Alright, so 7.6 would be enough in order to make that error disappear, but of course we specify the real version that we're actually using. So give this one a save, close it up, and so now our error here is actually gone. Now just one more step before we can actually try this out in our Postman app, and that is that we actually need to handle errors. Okay, and so keep in mind that with async await, we need to test for errors using the try-catch syntax. So we write a try block, then wrap all our code in there, and then finally a catch block, which, as we already know, has access to the error object. And now, what do we actually put here? Well, we need to think about when exactly an error can happen. So remember like 2 lectures ago when we were creating our first documents. We got an error back then when we tried to create a document without one of the required fields, right? And so that was a validation error, and it's one of the errors that would get catched here. Okay, because if we tried to create a document, let's say without one of the required fields, then this promise that is created here would be rejected. Okay, and so if we have a rejected promise here, then it will enter the catch block. And so therefore, basically in this catch block here, we want to send back a response saying that there was an error. All right, so res.status here again, and 400, which stands for bad request, .json, and now something very similar to this one, but it's status, and that's fail. And then instead of data here, we send a message. And for now, let's just set the message to the error. All right. And let's now finally get back to our Postman application and give this a try. Okay. So create this one, and let's now create a new tour. So right now here, we have the name, duration, difficulty, and price. And so let's actually also add the rating. And that needs to be in double quotes 4.7. All right, and now comes the moment, send, and indeed, here we go. So, this is the tour that we just created. We have our rating, we have our name, and we have our price, and of course the automatically created ID. Now you might notice that we have no difficulty and no price. Well, why do you think that is? Well, that's because these 2 fields are actually not in our schema, and so therefore they are not put in the database. So everything else that is not in our schema is simply ignored. So that is the power of our schema. All right? Great. Now let's actually try to send this again, and so that should give us an error. right? And indeed, here we go. We have our 400 bad request, and we have this message, which is the complete error that we got. And so here we see that the error message is duplicate key. And so that's because we already have the test tour 2, and so it could not create another one. So let's just create another one here, like Jonas tour. It doesn't really matter, okay? I just want to create it, well, first without any of this, just to see if we get another error. And indeed, we get some more errors here, this time saying that the tour validation failed because a tour must have a price. Okay, so you see that right now we have this kind of weird error structure here. So MongoDB gives back this huge complete error object, and later on we're actually going to take care of that. So we will have an entire section on error handling alone, and by then we will create some more meaningful errors. Okay, for now let's just replace this error object with some normal string here. So let's say invalid data sent. Okay, so don't do something like this in a real production application. But again, we're going to have some real error handling a bit later, which is going to take care of that. Okay, so displaying meaningful errors to the client. So let's just go back here, send it again. And so now we get this normal string here. So let's just create the price here. Let's set it to 5, 6, 7, then send it. And so now you will see that our default rating here is actually still working. Let's now figure all of this out in Compass as well. And indeed, we get our 4 tours in the database. So all these weird tests that we've been doing up until this point. So let's just go ahead and delete these last 2 that were really just for testing. All right. So something went wrong here, I guess. Okay. Now we're back to these 2. Let's now just create the third one that we actually had before in the last section, which is the snow adventurer. So the snow adventurer, the price was, I'm not sure anymore, like 697 maybe. And the rating is like 6, or actually 4.8. Send that guy. And so indeed, here we go. Great. Just to quickly recap or create tour function. So we have a try catch here because we're actually using an async await function here, right? So we use async await because this tour create returns a promise that we're awaiting so that we can then store the newly created tour document inside of this variable and then send it along with the response to the client down here. Okay? But in case there is an error, like a validation error, for example, then that error is going to be catched and we send something else back to the client with this error message. So this is how we create documents using Mongoose. Next up, we're going to talk about reading documents. Hey there! So let's now learn how to read documents with Mongoose in order to implement our getTour and getAllTours route handlers. And starting with the getAllTours handler. So first off, let's delete this piece of code here. And now what we're going to do in order to get all the tours from the database is to use tour, so the model again, and then on there we use the find method. All right. So remember from the MongoDB intro section where when we wanted to query for all the documents, we simply used find. Okay. And so here it's the exact same method. And again, when we don't pass anything into it, so just like we're doing here, then it will return all the documents in that collection. Okay. So in this case, in the tour collection, obviously. Now, just like before, this is going to return a promise that we will await. And since we want to await, we need to make this an async function. So async, then here we can await and save the result into tours. All right, and that's actually it. So let's get rid of these comments here. We also don't want the requested add property. So that was just for testing before. And so, yeah, I think that's it. So this is how we get all the tours from the tour collection. So using find, then awaiting that result, and then sending it down here. So remember that we have this data property here to basically envelope the tours. And then we also send this property here, which simply measures the number of results that are in the tours array. Okay, because of course this find method here will return an array of all these documents and will also very nicely convert them into JavaScript objects. Okay, so this function here, this find method, really does all the work for us. Now, just like before, one more step before we can actually try this out, which is to wrap all of this here in the try block and then catch any potential errors. Now in this case, there are not going to be any validation errors like before, but let's still send an error here in this case, and let's just make it a 404. And it doesn't really matter so much at this point, because again, we are going to implement some better error handling here in the next, or in one of the next sections. All right, so let's just set it here to status fail, and the message to whatever error that we might get here. Okay, so let's test it out now. It's this one, get all tours, and yep, it works. So here we have the array of the 3 tours that we currently have in our database. Perfect. So next up, let's implement the getTour handler. So that's right, the next one that we have here. And let's get rid of this code and this code. All right. And this one is actually going to work in a very similar way. So I'm still doing this try catch here. So error like this, because we're still using async await in this one. So async, because now in order to find one tour, we are still going to be awaiting tour.find, but it's not going to be just find, but instead we're going to use find by ID. All right, so find by ID, but where is that ID actually coming from? Remember that? So let's actually take a look at the route. So going back here to Postman, this is how we call this endpoint. Or let's actually put a more real ID here already. So for example, this one from the park camper. And so our request might come from a route like this. And so here we have this ID parameter right in our route, right? So let's take a look at our router here. And so remember that this is how we specified the ID in the URL. So this ID is going to be part of the request, obviously. And so how do we actually get access to that ID here in this handler? Well, we do request.params.id. And it is ID because that's what we called this variable here, right? If it was name here, then here we had rec.params.name, right? Remember that? And now let's save that to tour. All right. Then let's get this code here back. Copy it here. And then also this one for the error block. And don't worry, I'm going to explain this function here in a second. I just want to finish this code here first. So this piece of code here is going to be exactly the same for this catch block. Give it a save now. And so we get no errors here from ESLint. Now about this find ID method here, well, remember how up here we just used find. Okay, so find is to find all of the documents, and then we also have find one to find only one document. Okay, and so this find by ID is really just a shorthand, so a helper function for, let me write it here as a comment, for writing find one and then with the filter object, which is exactly like we learned in the MongoDB intro section. So we have the ID field, and then we could set that to rec.params.id. So this here would work the exact same way as this. Okay, so underscore ID, because that is what the ID looks like. So in MongoDB it's called underscore ID. And we could of course query for that field, right? We did exactly that in the last section. So we specified this filter object here, and then the property that we're searching for, and then the value that we want to search for. So exactly the same again as we did in the last section. And this find1 method here will then only return one of the documents. Now this find by ID, as I mentioned before, is simply a shorthand for having to write this. So behind the scenes, it's going to do exactly this, but Mongoose simply wants to make our life easier and therefore gives us access to an easier method called find by ID, which simply expects the ID that we're looking for. All right. So let me actually leave that here just as a reference. And so now this should actually work already. So let's take a look at that. So we already put the ID of this tour. I think it was this park camper. So AC2 and AC2, that should be the park camper. And indeed it is. Great. And that is the easiest way of finding or of querying documents from the database. There is a ton more that we can do with queries, and we're going to do all of that once we start implementing something like filtering or sorting or pagination and all that good stuff a bit later in this section, so in a couple of videos from now. At this point though, it's enough to simply return all of the documents here in this route handler, and then here simply the one for the matching ID. And that works now, and so let's move on to the next one. In this video, let's implement document updating. And so here in our update tour handler, let's start by making it an async function. Then our try catch block. And so I'm doing this very quickly now because we're already used to this at this point. Right? So this goes into the try block, and then I simply get this one here from the catch block of this other function. All right, so here we go. And so now what we need to do here at the beginning of this try block is to basically query for the document that we want to update and then update it. All right, and we can actually do that all in one command with Mongoose. And remember again that we're going to update a tour based on an ID. Okay, so it's a similar situation like this one here, where we find by ID. And now we can actually do something very similar, which is find by ID and update. So again, everything in one query. So let's do tour dot find by ID and update. Okay, so what do we need to pass in here? Well, of course, the ID, so that we can first find the document that is to be updated. So just like before, that is rec.params.id, and then the data that we actually want to change. And that data will be in the body, just like in the post request. So rec.body. Okay? And then actually as a third argument, we can also pass in some options. And we will do that. And the first option that I want to specify is new and set it to true. Because this way, then the new updated document is the one that will be returned. And since we want to send back that updated document to the client, we always want this method to actually return that new document. Okay, so this way it actually then makes sense to await this query and then save it to a new variable. So let's simply call it tour here, and then again await the result of this query. So all of these methods that we've been using on the tour so far, so find by ID and update, or well, not really create, but find by ID or find, all of these will return queries. So they are query methods. And let me actually show that to you in the Mongoose documentation. So up until this point, we didn't have a look at the documentation so far. And so let's quickly do that. So on the model, which in our case is tour, we have all these query methods, right? So you see find one, you see find by ID, which is just a shorthand for find one. Then you see find by ID and update, which is the one that we're currently using, and which in fact is just a shorthand for find one and update, where we're querying for an ID. So similar to what we had in the last lecture. Okay, and actually we can click on any one of these. So let's do the one that we're using currently. And that will then really take us to the API documentation, which shows us how to really use a certain method. So you see that we pass the ID, so the value of the ID to query by. We pass the object with the data to be updated, and we pass in an options object. And down here, we can actually see the options that we can set. And so remember, we just set new to true. And so as it says here, that will then return the modified document rather than the original. Now another one that we actually want to set to true is this run validators. So that each time that we update a certain document, then the validators that we specified in the schema will run again. Okay, and we will talk a lot about validators and validation a bit later in the section, but I'm gonna leave it here for now so that we basically don't forget it. Okay, so give it a save now, and actually I want to go back here just to show you how many methods we actually have in Mongoose. So on the model, we have all of these methods here that you see in this list. So for example, we used create before. We also used find. Okay, and so the ones that you see here in the top, they are available right on the model. And that in our case is the tour. Now down here, you for example also see model.prototype.save, for example. And this one we actually also already used right when we first started to work with Mongoose. So I'm not sure if you are familiar with this, but in JavaScript, model.prototype always means an object created from a class, or in this case, created from a model. And so this save method here refers to a save method called on a document and not on a tour. And remember that that's exactly what we did. And I think I still have it here as a comment. Yeah, right here. So we had a tour, this new tour variable here, which was created from the tour model. And so this new tour here got access to the save method because that is part of the prototype object of this class. All right. Now, I don't want to bore you with the fundamentals of JavaScript, but it is important in order to understand the documentation, okay? Because at some point you will need to use documentation because Mongoose is huge. And I will actually teach you a lot of the stuff that's important in there throughout of this course, but sometimes you will still need something that I didn't show you in this course. And so it's important that you really understand the documentation as well, okay? And so again, when you see model.prototype here, you know that this save method here is going to be available on all of the instances created through a model, okay? And so not the model itself. So for example, if you tried tour.save, you wouldn't be able to use it. It would give you an error. But instead, if you tried save on a document created through the tour, then it would of course work. Okay, I hope that makes sense. And anyway, you see that we have a lot of other stuff. So we have the query, which we already talked about. Because, for example, find by ID and update, or find by ID, all of these will return query objects. And so later on, when we're going to implement stuff like sorting or filtering, we will then use this query object. Okay, so let's go back. We kind of got off the track here by looking at the documentation. But again, I think it's really important to start looking at the documentation because a course like this can only take you so far. And I hope you already know that at this point. Okay, it's really important that you're also able to find information on your own, and I want to show you how to do that also in this course. Anyway, let's now actually also send this newly updated tour back to the client, which right now we're not doing because we have simply this updated tour here string. So let's get rid of that and simply send the tour. And remember that this in fact is actually this. So the tour property is set to the tour object, but thanks to ES6, we no longer have to do that when the property name has the same name of the value. Okay, so let's get rid of that. That makes our code look a bit better. Okay, and let's now test it. Back to Postman. Here we have the updated tour route. And so let's actually do it on this same ID that we used before. So this one. Then we come to the body here and let's change. Well, what are we going to change here? Well, let's change the price to like 500. So price 500, send it, and indeed, this gives us the newly updated object with the price already set to 500. And if we now get all the tours, then that of course should be reflected here, and here it is. But now let's say that we set it to a string. Let's take a look at what happens then. Well, then we actually get an error. And that's because we run the validators again. So remember that we have, where is that? Oh yeah, here. So here we specify that the validators should be run again. And so right now, the price is no longer a number as it is expected, right? So in the schema, we say that the price should be a number. But of course, JavaScript or Mongoose actually cannot basically convert this string here to a number. But that is what we expect. So here it says kind should be number. And so, therefore, it gives us an error, simply because we're running the validators again. So let's put it back to 500, and then, of course, it's going to be back. All right, now keep in mind that we're actually doing a patch request here. Now, if we were doing a put request, remember, then we would expect that the original object would be completely replaced with the new one that is sent in. Okay, and so in that case, it would no longer work the way we implement it here, because this one simply really updates the fields that are different here in the body. Okay, but anyway, I think that the patch method is actually way more useful, and so that's going to be the only one that I'm implementing here. Cool, so we have 3 of our 4 CRUD operations implemented, only one more left to go, which is going to be delete. And now, as the final one of the 4 CRUD operations, we have deleting documents. And so by now, this should already be pretty familiar. And that's why I want to leave this one to you as a challenge. All right? So again, this one is going to be pretty similar to update tour, only with a small number of differences, but I think you can figure out how it works, for example, using the documentation, and of course the other handler functions as an example. Okay, so keep in mind that here, for example, we used find by ID and update, and so you probably can already guess how this method is going to be called in delete tour. All right, and again, if you're not sure, you can take a look at the documentation and what kind of data it expects, and then based on all that, try to implement it. Okay, so please pause the video here and take a minute to really try to do it on your own. Okay, hope you got that one to work. And anyway, here goes my quick solution. So again, defining this one as an async function. Then try catch. Here is the error. And then let's move this one up. Get this error response from over here. And now we are going to use tour.find by ID and delete. And now all this method here actually needs is the tour ID. So rec.params.id. And I hope you figured this one out from the documentation. Then of course we need to await in order for the deletion actually to happen, and that's actually all. So in this case we actually don't save anything to any variable, because remember, we actually don't send anything back to the client. Okay, so in a RESTful API, it is a common practice not to send back any data to the client when there was a delete operation. Okay, and also the 204 is kind of a standard as well. So give this a save now, and it should actually already work like this. And so to start, let's just create some stupid tour here. So let's create a Jonas tour here, give it a save. And so when we get all tours, indeed, it's going to be here. And so let's go ahead, copy the ID, then open or delete tour route here. And then all we need is to really send this delete request to this route. Hit send. And so again, we get back the 204 status code. And Postman, in that case, actually doesn't display anything. All right. And just to make sure, let's confirm it very quick. And yeah, it's gone from here. And so our tour was effectively deleted. Okay. Now, if you didn't manage to complete the challenge on your own, then of course that's no problem at all. I just wanted you to think about it, and most of all, take a look at the documentation on your own, because it really makes all the difference for you to start practice this kind of stuff as soon as possible. Anyway, with this, we implemented the basic CRUD operations. In the next video, we will then finally really start to model or tour a bit better. So right now we only have names, prices, and ratings, and that's not really enough to describe a tour. And so, yeah, in the next video, we will kind of create a better, a bigger, so a more complete model. So I hope to see you there soon. So now that you know the basics of Mongoose by implementing all the 4 CRUD operations, it's now time to finally model our tour data a bit better in order to make the tours more complete. So at this point, our tour documents can only have a name, a rating, and a price. But of course, we need so much more data here, because the goal is to have a very data-rich API like this one. So let's take a look at the final version actually here as a reference. And so that's this one here. And so we get all tours, and it's gonna look a bit like this. Okay, so you see that on each tour we have a start location, we have ratings average, ratings quantity, images, start dates, guides, name, duration, maximum group size, difficulty, price, summary, description, image cover, locations, even a slug, reviews, duration in weeks, and the ID. So you see a lot of data, and we're not gonna add all of that data in this lecture here. There are some pieces that we cannot add as of yet, but we can, of course, make it a bit more complete. Okay, and let's actually save this here, like as the reference, and get all tours, and I'm gonna put it outside of any folder. So let's put it just here at the top. No, that doesn't work for some reason. Okay, let's just put it here then. Okay, let's get, so that's correct. And so again, I'm leaving it here in order to keep comparing what we have with what we're aiming for. So anyway, let's go back and start with what we have already. And we have the name. And so that's already good enough. So for now, I'm going to leave it like this. So the name. Then we also want a duration. And that duration is a number. And it is required. So set it to true. And then the message is a tour must have a duration. So these required validators here basically are the only validators that I'm going to add to each of these fields here for now. Later on, when we're going to talk more in detail about validators, we're going to add a lot more. But again, for now, I just want to make some of these fields, not all of them, required. Next up, we have the group size. So basically, how many people can at most take part of one tour. And so I call that one the max group size. And so that, again, should be a number. And it is, again, required. Tour must have a group size. Don't forget the comma here. Next up, we also need a difficulty. And this one is a string. And later on, we will define that it should be either medium, easy, or difficult. But again, that is actually a validator, and I'm going to leave that for a later time. Okay, for now, I'm just saying that it should have a difficulty. Next up, let's talk about the ratings. So right now we have a field called rating, but in fact we want to have one field for the rating average and one field for the ratings quantity. So basically the amount of ratings that there are. So later there will be another resource called reviews, where users will be able to write reviews about tours and give ratings. And that's going to be a completely different resource and a completely different model. But still, we want to have basically a summary of these ratings and of these reviews here in the tours. All right. And the reasons for that you will learn a bit later once we start how and why we model data in NoSQL databases and specifically in MongoDB. Okay, for now, let's just add the ratings average and the ratings quantity. Okay, so we leave this here as number and with this default. And the ratings quantity, that should of course also be a number. And the default will be 0. Because of course, in the beginning, there will be absolutely no reviews when a tour is new, right? Now I didn't give these two properties here a required value because it's not the user who creates these tours who will actually specify these values, right? So when we create a new tour, we will never specify the ratings average, neither the ratings quantity, because that will later on be calculated from the real reviews, okay? Next up, we have the price here, so that's fine like this, and we might also have a discount. So let's say that this company, so Naders, wants to give a discount to one of the tours at some point, and so they can specify a discount price here as well. So price discount, and so let's just put it here at number. We don't need any schema type options here. For example, it's not required, and so for now, let's just leave it like this. Next up, we can specify a summary of the tour. So the summary is of type string, but I will not actually make it required. Okay, and that's simply because it's not on the front page of our website. Okay, so basically it's not on the overview. And I'm going to show you that in a second, but for now let me just add here another schema type option that I didn't show you yet, which is called trim. And trim only works for strings, and I will set it to true. So remember how I said that there are different schema types for different types here. And so for string, we have a schema type, which is trim, which will remove all the white space in the beginning and in the end of the string. Okay, and so if someone enters, for example, this tour, blah, 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 doesn't matter. So if someone enters this, then all this white space in the end and in the beginning here will get cut. Okay, and actually we can put the same thing on the name, for example, here. Okay, why not? So let's leave it like this. Here I see that it's actually called duration, not durations. All right. So that's the summary, which is also misspelled. So summary like this. Oh, and yeah, now I wanted to show you the Nader's website actually. So that's back to our Mongoose documentation. But this is what I want to show you. So naders.dev, which is the original of this application. And so this is the data that we have in our API and that we also, of course, need in the database. So we have all this data. So this tour name, we have the difficulty, we have the duration, we have, this is a summary. Then we have a start location, we have the amount of locations, we have a start date, we have the maximum group size in here, and we have the price, the rating average, the rating quantity. We also have an image here. And then here on the details page is where we have the summary down here. We have the guides that I just showed you in Postman before. We have some more images. We have here all the locations, and we have all the reviews. Okay. So as I was telling you, not all the data is on the overview page, and so not all the data is also required. Okay. So let's move back here. Next up, I want to add a description. And this is a type of string. And let's set trim to true again. And I just remembered that the summary is actually on the overview page. And so let's make this one required. So do that here at the end. True. A tour must have a description. Okay, next up, we will specify the image cover. So that's the images that you see on the overview page. And so let's set this one actually to required as well. So the type should be string, because basically this will simply be the name of the image here, which then later we will be able to read from the file system. Okay, so really just the name of the image. So basically a reference will be stored in the database. And that's a very common practice. Okay, so I mean, we could store the entire image as well in the database, but that's usually not a good idea. We simply leave the images somewhere in the file system and then put the name of the image itself in the database as a field. So set it to required, true, a tour must have a cover image. Nice. Next one is the rest of the images. And now here we have something new, okay? Because we have multiple images and I want to save these images as an array, and actually as an array of strings. And so the way to do it is to simply specify here an array of strings, just like this. So I want it still to be of type string, but I want it to be an array. So an array in which we have a number of strings. And so that's how I can define this. Okay, and we will use this later for something else again. And so we will then actually also pass in more schema type options than just a type. And so by then we will use that again, all right? For now though, let's move on. And the next field that I wanted to add here is the created at. And the created at field should basically be a timestamp that is set by the time that the user adds a new tour. So this here should of course be added automatically, again, at the time the tour is created. So how do we do that? Well, first of all, we set the type to date. So tape is yet another JavaScript built-in data type. And so we can use that here. Okay, so the type is date, and then we simply need to set a default. And the default is the JavaScript built-in function date.now. And I'm sure you are familiar with this one. So this will simply give us a timestamp in milliseconds, which basically represents the current millisecond. All right. Now in Mongo, this is then immediately converted to today's date in order to make more sense of this data. Okay. So yeah, so that's the automatically created timestamp. And now finally, we need to also pass in an array of dates. And now finally, to finish for now, we also want to be able to define an array of start dates. So start dates, and again, we simply define an array and then say that in there we want dates. All right, so these start dates are basically different dates at which a tour starts. For example, we can have a tour starting in December this year, and then in February the next year, and then another one in the summer. And so different dates for the same tour are simply different, let's say, instances of the tour starting on different dates. All right, I hope that makes sense. Anyway, this one here will not be automatically created by MongoDB, and MongoDB will then automatically try to parse the string that we passed in as the date into a real JavaScript date. For example, we could pass in something like, let's say, 2021, March 21st, and again, Mongo would then automatically parse this as a date. We can also specify the date, for example, saying 11 and 32 minutes, all right? Or we could also simply input a Unix timestamp, so a timestamp like in this format here, okay? And so all of these formats, basically Mongo will try to parse them into a date. And only if it can't, it will then throw an error. Phew, so this was a lot of work. Let's give it a save here. And the way that we can try this out is to go here to our dev data, where we have this toursimple.json file, which is the one we've been using in a previous section. All right. And so all I'm going to do here is to just grab all this data here and then use that one to create a new request. Okay. So we want to create a new post request here, and with all that data, instead of having to write it out manually. Okay, so pasting all of this here, and now indeed we do not need the ID. So we needed it before when we were doing our file-based API, but that's over now, so let's get rid of that. And so all the rest of the data that we marked as required is now actually here, and even some more. So let's try to see what happens when we submit this. And now we get invalid data sent. So let's actually go to our tour controller, and in here where we create the tour, instead of this message, let's actually go back like we had it before and send the entire error just so we see what is actually going wrong. So send it here. Okay. And the problem was that we have the snow adventurer already defined. So let's first get rid of that. Yeah, so here we have the snow adventurer. So we should delete this. And for that, I'm using our own API, so we can already put it to some use here. So that one should now be gone. And so now we should be able to add this as a new tour. And indeed, it's now here. So here is all the data that we just specified in this nice format. So what is interesting now is to actually see the created at timestamp. So that's the exact time at which I'm recording this video. And so this one was, of course, automatically created by this piece of code that we have somewhere here. Yeah, this. Okay, so that date is coming from this date.now timestamp that JavaScript then automatically parses to this nice and readable date. Then here we have these arrays. Okay, so this array and another array, and of course the automatically generated ID. All right. So if we come here now, we then have, of course, 3 tours. First, the other ones which are not so complete, and then all of these. Now, what's interesting to see here is that Mongo also actually updated kind of the tours that we already had. So, for example, we had rating here, but now that our schema completely changed, it then added this ratings average and also this ratings quantity, both to their defaults, and the same actually here. It also created this timestamp. It created images and start dates with these empty arrays. And so it kind of changed all this data here. All right. And so before we start moving on in the project, we should probably go ahead and delete all of this data here. All right. And actually what we're going to do in the next video, now that our model is finally completed, at least for this section, we will go ahead and write a small script which will automatically import all of the tours from this JSON data. Okay, so from this JSON file, actually. So it will basically read the file, get all the tours, and import them into the database. All right, so that's what we're going to do next, because that will be hugely useful in this section and also in the future. Let's now take a small break from building our API and build a fun little script that will import the tour data from our JSON file into the MongoDB database. And I wasn't really sure if I should include this video in the course or if I should just come with this script already in the course starter files. But I thought it was a nice little exercise, and so I included it anyways. So anyway, let's now get started. So basically, we're going to create a script that will simply load the data from the JSON file, as I just said, into the database. And this script is completely independent of the rest of our Express application. And so we will run this completely separately from the command line just to import everything once. Okay, so let me actually create this script right here in the data folder. So new file, import devdata.js. All right, so what are we going to need for this? We will need Mongoose, of course. So let's start with that. Or actually, let's just go ahead into the server.js file and copy this stuff, because why writing it all over again? So let's copy everything and then delete what we don't need. So we don't need our Express application. We also need the .env package because we need our environment variables in order to be able to connect to the database again. Okay, and we need to connect to the database in this script again because it runs completely independent from the Express application. It's only going to run once in the beginning. Next up, we need access to the file system module because, of course, we want to read the JSON file. So require fs. And finally, we also need access to the tour model, because the tour model is where we want to write the tours to, right? So tour equals, and now let's find the path there. So from the place where we are right now, we need to go up one level. And what's going on here with these quotes? All right, so one level up and we're in dev data. So we need another level up so that we're in the main folder, and from there we go into models and into the tour model. Okay, and that should be it for setup. Now let's start by reading the file. So read JSON file, and that should be fairly simple. So the tours are at fs.read file, and we can use the synchronous version, of course. And let's simply say tours simple.json. Okay, and then also the encoding. So file encoding UTF-8. Give it a save. And so now we can write the actual function that is going to import the data into the database. So import data into database. Okay, just like this. And so let's create this function, import data, yeah. And it's going to be an async function, which does not need any arguments. And so let's again use a try catch block here. And here, I'm simply going to log it to the console if there is some error, just to know what's going on in that case. And now here, what we will do is very simple. We are simply going to wait tour.create. So we already used tour.create, and we passed in an object back then, right? But the create method can also accept an array of objects. And in that case, it will then simply create a new document for each of the objects in the array. So very simple. All we have to do is to specify our tours data here, right? And actually, it's not 100% correct because remember that this is JSON. And so we need to first convert it actually into a JavaScript object using json.parse. Okay, and so now we actually have an array of JavaScript objects that we can now pass into the create method, okay? And if that was successful, then the next line is going to be executed. And so here we can say data successfully loaded. All right, and this should already do the job. Now, what about the data that is already in the database? We can also create an easy way to basically delete all of that data at the same time. And so let's simply go ahead and do that as well. So delete all data from collection, let's say. And this weird yellow color that you see here actually comes from an extension that I have installed here. And so to get rid of that, I'm simply going to write database again. Okay. So delete data. And again, this is going to be an async function without any arguments. And let me actually copy this code here. So delete it. And now about the deleting itself, we can use the delete many function. Okay, and actually I showed you this one back in the intro to MongoDB, right? Where we could use delete many and then simply pass in nothing in there, and that would then delete all of the documents in a certain collection, right? And so Mongoose basically implemented the same function here on the model. Okay, so in this case, the tour model has access to this delete many method, which will then do exactly the same as delete many does in native MongoDB, right? So remember that Mongoose is just like a layer of abstraction on top of MongoDB, which is why it doesn't use the exact same functions, but it still gives us access to some similar ones, or to ones that actually have the same name. So delete many actually has the same name as the native MongoDB function. All right. And so again, what this is going to do is to simply go ahead and delete all the documents in the tours collection. So we have our two functions here, but if we now actually run this file, then nothing will happen. And that's because we're not calling any of these functions anywhere, right? Now we could go ahead and simply write something like import data here and then simply call the function here. But I wanted to make this a little bit more fun. So let's now actually learn a tiny little bit about interacting with the command line. Okay, and so I'm actually gonna go ahead and run this file without calling any of these functions, but instead I'm gonna log to the console process.argv. Okay, just so we can see what process.argv actually is, so that we can then use it. All right, so let me open up here another terminal, and then I will use node, go into dev data, then into data, and then in there import dev data. And we get some errors here. Let's see where. Yeah, so it's because of this file name. So I guess we should specify the path to there basically. So let's run this one again. And again, we have this error. And yeah, of course I get this error. Now, so that's a stupid one. Remember how I told you that this dot here is always relative from the folder where the node application was actually started. And so that's the home folder. And so we're basically looking for this file here in the home folder. Okay, so what I should use instead is the dir name variable that is available to us everywhere. So that goes like this. All right, give it another save and clear up the console and run it again. And so now it works. And so here is the result of this console.log that we have down here. So process.argv. And basically that is an array of these two arguments of running this node process. So this here is basically where the node command is located. So that's equivalent to this node. And then the second one, so this path to this file is actually this here. Okay, so let's quit this here and let's add kind of an option here. So I'm going to write -- import. And so I'm sure you have seen something like this many times before. For example, when we save a package as a dev dependency, we do it like this, save dev. And so we use the same kind of format for specifying options. Okay, so -- and then whatever string we put here. And so I choose to basically specify the import option like this. And so you see that now the third argument is -- import. All right. And so that means that we can now go ahead and basically use this data here in order to write a very simple command line application, basically, which will import the data when we specify this option and will delete the data when we specify the delete option. All right. So let's actually do that. So if process.argv, and it's an array, and we want the third, so 0, 1, 2. So if that element is equal to import, well, then we want to run import data, right? If process.argv2 is equal to delete, then we want to run delete data. And that's it. So that should actually give us the result that we're looking for. So let's finish this here. And so now let's run the command here with delete in order to delete all the data that we have in the database. So let's try that out. It's doing something, and data successfully deleted. So let's take a look at that now. And if we run now this get all tours route, then indeed we have 0 results. So all our tours are now gone. So it worked. Now this process here is basically still running. And so let's quickly fix that, which is kind of easy. So that's a new one we haven't used yet, which is process.exit. All right. Now this process.exit is kind of an aggressive way of stopping an application, but in this case it's no problem because it's really just a very small script that we're running here and not a real application, right? And let's just copy the same thing here into our import data function. And so now I'm gonna quit it, and just to show that it works, I'm gonna run it again. So data successfully deleted, and then it exited the process. All right, and so now it's time to actually run the function that we were interested in the first place. So with the import flag, basically, so the import option. So let's run that, and let's see if it actually works. And it didn't. So why is that? So it tells us here a tour must have a group size. So where's that coming from? And we see a lot of validation errors here. So something must have gone wrong here. So yeah, we have the cover image, we have the tour description, we have the price. Well, that's weird. The max group size. Let me actually check if anything happened here. Actually, we have 9 tours here, and I think 9 is actually all we have. And so to me, it kind of looks like it actually did work. But let's actually take a quick look at our data here. So just to figure out why this actually happens. So tour simple here. And so we can already see actually the problem that is happening. So we have all these tours, so the original ones, but then from the last section, we have these 3 here that we kind of added using our file-based API. So remember that? So back then we only specified the name, duration, and difficulty. and nothing else. And so right now, our script is trying to import these 3 tours. But of course, we're not interested in them at all. And so let's go ahead and save this here. Okay. Then quit this process. And so actually this process.exit can be outside of the try catch block and be simply here by the end of the function. So that no matter if there's an error or not, it will always just exit the process. All right. So let's delete everything. All right, clear the console again. Now import. And yeah, so data successfully loaded. And indeed, here we are again. So now it's working 100%. We have our data that we can start working with now. And so, yeah, our work with this one here is done. So a nice little function, or a nice little script actually. I hope that everything made sense to you. And yeah, that it was kind of a fun exercise for you as well. Anyway, see you in the next video where we are finally starting to then use all this data and to improve our API by implementing a couple of nice features. Let's now keep working on our API. So over the next videos, we will implement a couple of common API features that make an API easier and more pleasant to use for whomever is going to use it. And in this lecture, we're going to start with filtering. So again, the first feature that we're going to implement is to allow the user to basically filter data using a query string. Okay, so let me just show you what a query string is using Postman. Okay, so let's close all these guys. All right. And so actually where filtering is going to make sense is here on this get all tours route. Okay. Because this is the one that, well, as the name says, gets all the tours. And so here we want to allow the user to filter the data so that instead of getting all the data, he only gets the data that matches the filter. Okay. And so like this, we can basically allow the user to query the data in a very easy way. Again, using the query string. And the query string looks a bit like this. And I'm sure you've seen it. So we start with a question mark, and then we can simply specify some field value pairs. So let's say we wanted to filter for a duration equal to 5, and at the same time, a difficulty of easy. Okay, and so we can very simply build a query string like this. So again, it starts with this question mark, and then we can specify as many key value pairs using this format. Okay? And now our Postman application here actually recognizes this, and so basically parses this string here, and puts the key and the values down here in this param tab, right? So we could also specify the key and values here. So let's say test, set it to 23, and so you see up here that it actually added it to the query string. So that's a very nice way of Postman helping us here. Because now we can, for example, while we're doing testing, we can turn these on and off, and you see that the query string then here reacts accordingly. Okay, anyway, we now need a way of accessing this data that's in a query string in our Express application, right? But luckily for us, that's very easy, because Express already took care of that. So that's just one of the many things that Express does for us in order to really make Node.js development a lot faster. Okay, so let me show it to you here actually in the console. Okay, and so this data is on a request, which makes sense, and then it is in a field called query. Okay, so request.query should then give us an object nicely formatted with the data from the query string. Okay, give it a save. And note how I actually added it to the get all tours handler function, right? So again, we do this kind of filtering in the route where we want to get all the tours, okay? So let's test that out now. With this exact query string, send the request, And coming back, here we get the object. So let's actually make this here a bit bigger so you can see. That's not really working. So sometimes I know that some people cannot see the bottom of the screen. So let me just do it again here. And so here we go. So we have the object, which has the duration set to 5 and the difficulty set to easy. And so you see that Express very nicely parsed that string into this easy to use object. Now one thing that I noticed here is that we're actually missing the log that we had easier here in the console. So let's take a look at why that's happening. And so for some reason, we now have the application before we actually read the environment variables. And so that way the application does not get access to them. So I thought that I had fixed this before, but for some reason it's back now. So give it another save here, and I will try that again. And so now we get our logging back. Okay, so a GET request to this URL, and then with this rest of the data here. All right. Anyway, let's now actually use that data in order to implement our filtering. But before we can do that, I need to tell you that in Mongoose, there are actually two ways of writing database queries. The first one is to just use a filter object, just like we did in the MongoDB introduction section, right? Remember that? And then the second way is to use some special Mongoose methods. Okay, so let me just very quickly show that to you. So with the filter object, we would do it like this. So we start with the find here, and then in there we can pass a filter object. And I already mentioned that before. And so again, it works the exact same way as with a normal MongoDB query. So we could now say duration, set it to 5, and then difficulty, set it to easy. Okay, and so that's exactly the query string that we had before. And now I'm hard coding it here just to show you the two different ways of writing queries in Mongoose. So let's test this one out. Okay, and so you see that now we only get 2 results. Let's give ourselves some space here. All right, so we see the 2 results, and indeed they both have a duration of 5. So here and here, and they both are easy. So easy and easy. Okay, and so our filter worked just fine. So that is the first way of writing a query, just the normal way that we're already used to, but there is another way. So let me show that to you as well. And again, we start in the exact same way. But then the difference is that we start chaining some special Mongoose method to basically build the query similar to this one that we have. Okay, so we say where the duration equals 5. And then also where the difficulty, but net needs to be in quotes, equals easy. Okay, so this query here is going to be exactly the same as this one, but again, written using special Mongoose methods. And there are, of course, tons of other methods. So for example, instead of equals, we can have less than or equal, or just less than, or you can also sort the results or limit the number of results, and really all kinds of stuff. And for sure, we're going to use some of them over the next couple of videos. Okay, and so this might look a bit weird here to you, but it's actually very, very useful in some cases. All right, just to test, give it a try again to this one. And indeed, we get our same 2 results. Okay, now let me comment this one here out. So I'm going to leave it here just as a reference, because right now we're going to use this method here. And we're going to use it because, in fact, we actually already have an object that looks a lot like this, right? And so that is request.query. So if you compare it, this object that you see down here looks exactly the same as this one. And so to implement a very simple filter all we have to do in this case is to say rec.query. And so let's try that one more time. Let's get rid of this here. And indeed, we get the exact same two results. Now let's just try only with difficulty set to easy. All right, and so now we get 4 results. Okay, and all of them, of course, will have the difficulty set to easy, right? So our filter, or very basic filter, is now actually working. Now, the problem with this implementation is that it's actually way too simple. And that's because later on, we will have other query parameters, like, for example, sort for sorting functionality, or page for pagination. And so we need to make sure that we are not querying for these in our database. For example, if we added here page equals to 2, then we would, of course, not get any result. Let me show that to you. And indeed, we do not get any result because there's no document in this collection where page is set to 2, right? So we only want to use this parameter here, or this field page, to implement pagination and not to actually query in the database. All right? And so what we will have to do is to basically exclude these special field names from our query string before we actually do the filtering. Okay? And so let's now go ahead and implement that. So what we will do is to first create a shallow copy of the request.query object. Let's call it query object. And so here we need really a hard copy. So we can't just do like request.query, because then if we would delete something from this object, we would also delete it from the rec.query object. Okay? And that's because in JavaScript, when we set a variable to another object, then that new variable will basically just be a reference to that original object. All right? And so we really need a hard copy here. And in JavaScript, there's not really a built-in way of doing this, but a very nice trick that we can use since ES6 is to use first destructuring, which we use by using ... and then we can simply create a new object out of that. So just like this, okay? So destructuring here, these 3 dots, will basically take all the fields out of the object, okay? And then here with the curly braces, well, we simply create a new object. So we have a new object that is basically going to contain all the key value pairs that were in our rec.query object. All right, so that's a copy. Now let's create an array of all the fields that we want to exclude. So I'm calling that one excluded fields. And then we want to exclude page. So that's the one that I just showed you before in Postman. Then we also want to exclude sort. We want to exclude limit. And we want to exclude fields. Okay, so we will implement all of the functionality of paging, sorting, limiting, and selecting only some specific fields later over the next couple of videos. All right. Next, what we need to do is to basically remove all of these fields from our query object. And in order to do that, we will loop over these fields. So excluded fields for each. And we're using for each because we don't want to save a new array. And then each of these elements, we can use the delete operator. And then from the query object, we want to delete the field with the name of element. So the current element in the array. And so like this, we will first delete the field of page, then the sort, then the limit, and then the fields. Okay? Of course, only in case if it's there. If there is, for example, no limit field, then of course that will not be deleted because it's not there. All right. So let's now take a look if this actually works. So I'm going to log rec.query and at the same time or query object. Okay. So giving this a save. And don't worry about our results now. All I want to take a look at is our query objects just to make sure that this logic that we have here actually works. So let's add a sort here of 1 and a limit of 10. And these will make more sense later. For now, I'm just adding them so that I can later exclude them. Okay, so results don't matter. All that matters is that our original query is this one here, and then our query object, which is the one that we're going to use, only has difficulty set to easy. That's because we excluded page, sort, and limit. Okay, and so this now works, and so instead of using rec.query, we're going to use our query object. So let's get rid of that and try it again. And so now we should be back to querying for all the documents that have a difficulty set to easy and ignoring all of these other fields. Okay, so let's send that. And indeed, we are back to our 4 results that we had before, right? And we can also turn on the duration. And so indeed, we will now have 2 results, right? Remember that? And if we turn these off, well, then of course it's gonna work the same. Let's just delete this empty line here. All right. And so, yeah, indeed, with our original query string, things obviously also still work the same. All right, so we prepared our filter feature so that it ignores page and sort and limit fields. But there is actually something more that we need to do in our code in order to basically be able to implement these features in future videos. Okay, and so let's go back here to our code. And so let's now learn a little bit about how queries actually work in Mongoose. Okay, and I think I mentioned this before, but it's very important to talk about this again. So this find method here is going to return a query. Okay, so all of this here will return a query. And that is the reason why we can then chain other methods like this, like where, like equals, and yeah, so all these other methods that I talked to you about before. And let me actually show that to you in the documentation again. Okay, so here we have the query object. And again, when we use the find method, it will return an object, which is a query. Okay, and so in query.prototype, we then have all of these methods. So for example, down here, we have where, which I just mentioned. We have sort, which is the one that we're going to use later to sort. We have, let's see, we have less than or less than equal. We have greater. We have, what else did we use? We used equals. And so all of these are part of query.prototype, which again refers to objects that we're creating using the query class. All right. And so again, this is the reason why we can do this sort of chaining. And now comes the important part. So as soon as we actually await the result of the query, so as soon as we use await here, or here for example, as soon as we use this await, the query will then execute and come back with the documents that actually match our query. And so if we do it like this, such as we have here, then there's no way of later implementing sorting or pagination or all of these other features. Okay? And so instead, what we will have to do is to save this part here into a query, and then in the end, as soon as we change all the methods to the query that we need to, only then by the end we can await that query. All right? So for example, we're going to use the sort method. We're going to use the project method. We're going to use the limit method. And we're going to use really a bunch of methods and chain them to this query. And that would be impossible to do, again, if we await the result of this initial query here right away. Okay? So I hope that made sense. And so the way that we will do it is that we will have our tours down here. And this will await the query. And the query is, well, simply the query without any await. All right. And just to make it consistent with this part here, let's do it like this. Okay. So let's say that first we build the query and then we execute the query. All right. And that's not correct. All right. And since we're doing comments here, let's also say send response. Okay, just to make our code a bit more easy to scan. So I hope that all of this made sense. This turned out to be quite a long video, but it was important to finish this part here by explaining you this logic here so that in the next videos we will then be able to implement the rest of the features. All right? Because again, without having it like this, it would not work. Let's now keep working on our API. So over the next videos, we will implement a couple of common API features that make an API easier and more pleasant to use for whomever is going to use it. And in this lecture, we're going to start with filtering. So again, the first feature that we're going to implement is to allow the user to basically filter data using a query string. Okay, so let me just show you what a query string is using Postman. Okay, so let's close all these guys. All right, and so actually where filtering is going to make sense is here on this get all tours route. Okay, because this is the one that, well, as the name says, gets all the tours. And so here we want to allow the user to filter the data so that instead of getting all the data, he only gets the data that matches the filter. Okay, and so like this, we can basically allow the user to query the data in a very easy way. Again, using the query string. And the query string looks a bit like this. And I'm sure you've seen it. So we start with a question mark, and then we can simply specify some field value pairs. So let's say we wanted to filter for a duration equal to 5 and at the same time a difficulty of easy. Okay, and so we can very simply build a query string like this. So again, it starts with this question mark, and then we can specify as many key value pairs using this format. Okay, and now our Postman application here actually recognizes this, and so basically parses this string here and puts the key and the values down here in this param tab, right? So we could also specify the key and values here. So let's say test, set it to 23. And so you see up here that it actually added it to the query string. So that's a very nice way of Postman helping us here. Because now we can, for example, while we're doing testing, we can turn these on and off. And you see that the query string then here reacts accordingly. Okay, anyway, we now need a way of accessing this data that's in a query string in our Express application, right? But luckily for us, that's very easy because Express already took care of that. So that's just one of the many things that Express does for us in order to really make Node.js development a lot faster. Okay, so let me show it to you here actually in the console. Okay, and so this data is on a request, which makes sense, and then it is in a field called query. Okay, so request.query should then give us an object nicely formatted with the data from the query string. Okay, give it a save, and note how I actually added it to the get all tours handler function, right? So again, we do this kind of filtering in the route where we want to get all the tours. Okay. So let's test that out now with this exact query string. Send the request, and coming back, here we get the object. So let's actually make this here a bit bigger so you can see. That's not really working. So sometimes I know that some people cannot see the bottom of the screen. So let me just do it again here. And so here we go. So we have the object, which has the duration set to 5 and the difficulty set to easy. And so you see that Express very nicely parsed that string into this easy to use object. Now one thing that I noticed here is that we're actually missing the log that we had easier here in the console. So let's take a look at why that's happening. And so for some reason, we now have the application before we actually read the environment variables. And so that way the application does not get access to them. So I thought that I had fixed this before, but for some reason it's back now. So give it another save here, and I will try that again. And so now we get our logging back. Okay, so a GET request to this URL and then with this rest of the data here. All right. Anyway, let's now actually use that data in order to implement our filtering. But before we can do that, I need to tell you that in Mongoose, there are actually two ways of writing database queries. The first one is to just use a filter object just like we did in the MongoDB introduction section, right? Remember that? And then the second way is to use some special Mongoose methods. Okay, so let me just very quickly show that to you. So with the filter object, we would do it like this. So we start with the find here, and then in there we can pass a filter object. And I already mentioned that before. And so again, it works the exact same way as with a normal MongoDB query. So we could now say duration, set it to 5, and then difficulty, set it to easy. Okay, and so that's exactly the query string that we had before. And now I'm hard coding it here just to show you the two different ways of writing queries in Mongoose. So let's test this one out. Okay, and so you see that now we only get 2 results. Let's give ourselves some space here. All right, so we see the 2 results, and indeed they both have a duration of 5. So here and here, and they both are easy. So easy and easy. Okay, and so our filter worked just fine. So that is the first way of writing a query, just the normal way that we're already used to, but there is another way. So let me show that to you as well. And again, we start in the exact same way. But then the difference is that we start chaining some special Mongoose method to basically build the query similar to this one that we have. Okay, so we say where the duration equals 5. And then also where the difficulty, but that needs to be in quotes, equals easy. Okay, so this query here is going to be exactly the same as this one, but again, written using special Mongoose methods. And there are, of course, tons of other methods. So for example, instead of equals, we can have less than or equal or just less than, or you can also sort the results or limit the number of results, and really all kinds of stuff. And for sure, we're going to use some of them over the next couple of videos. Okay, and so this might look a bit weird here to you, but it's actually very, very useful in some cases. All right, just to test, give it a try again to this one. And indeed, we get our same 2 results. Okay, now let me comment this one here out. So I'm going to leave it here just as a reference, because right now we're going to use this method here. And we're going to use it because, in fact, we actually already have an object that looks a lot like this, right? And so that is request.query. So if you compare it, this object that you see down here looks exactly the same as this one. And so to implement a very simple filter, all we have to do in this case is to say rec.query. And so let's try that one more time. Let's get rid of this here. And indeed, we get the exact same 2 results. Now let's just try only with difficulty set to easy. All right, and so now we get 4 results. Okay, and all of them, of course, will have the difficulty set to easy, right? So our filter, or very basic filter, is now actually working. Now, the problem with this implementation is that it's actually way too simple. And that's because later on, we will have other query parameters, like, for example, sort for sorting functionality, or page for pagination. And so we need to make sure that we are not querying for these in our database. For example, if we added here page equals to 2, then we would, of course, not get any result. Let me show that to you. And indeed, we do not get any result because there's no document in this collection where page is set to 2, right? So we only want to use this parameter here, or this field page, to implement pagination and not to actually query in the database. All right. And so what we will have to do is to basically exclude these special field names from our query string before we actually do the filtering. Okay. And so let's now go ahead and implement that. So what we will do is to first create a shallow copy of the request.query object. And let's call it query object. And so here we need really a hard copy. So we can't just do like request.query, because then if we would delete something from this object, we would also delete it from the rec.query object. Okay, and that's because in JavaScript, when we set a variable to another object, then that new variable will basically just be a reference to that original object. All right, and so we really need a hard copy here. And in JavaScript, there's not really a built-in way of doing this, but a very nice trick that we can use since ES6 is to use first destructuring, which we use by using ... and then we can simply create a new object out of that. So just like this, okay? So destructuring here, these 3 dots, will basically take all the fields out of the objects, okay? And then here with the curly braces, well, we simply create a new object. So we have a new object that is basically going to contain all the key value pairs that were in our rec.query object. All right, so that's a copy. Now let's create an array of all the fields that we want to exclude. So I'm calling that one excluded fields. And then we want to exclude page. So that's the one that I just showed you before in Postman. Then we also want to exclude sort. We want to exclude limit. And we want to exclude fields. Okay, so we will implement all of the functionality of paging, sorting, limiting, and selecting only some specific fields later over the next couple of videos. All right. Next, what we need to do is to basically remove all of these fields from our query object. And in order to do that, we will loop over these fields. So excluded fields for each. And we're using for each because we don't want to save a new array. And then each of these elements, we can use the delete operator. And then from the query object, we want to delete the field with the name of element. So the current element in the array. And so like this, we will first delete the field of page, then the sort, then the limit, and then the fields. Okay? Of course, only in case if it's there. If there is, for example, no limit field, then of course that will not be deleted because it's not there. All right. So let's now take a look if this actually works. So I'm going to log rec.query and at the same time or query object. Okay. So giving this a save. And don't worry about our results now. All I want to take a look at is our query objects just to make sure that this logic that we have here actually works. So let's add a sort here of 1 and a limit of 10. And these will make more sense later. For now, I'm just adding them so that I can later exclude them. Okay, so results don't matter. All that matters is that our original query is this one here. And then our query object, which is the one that we're going to use, only has difficulty set to easy. That's because we excluded page, sort, and limit. Okay, and so this now works. And so instead of using rec.query, we're going to use our query object. So let's get rid of that and try it again. And so now we should be back to querying for all the documents that have a difficulty set to easy and ignoring all of these other fields. Okay, so let's send that. And indeed, we are back to our 4 results that we had before, right? And we can also turn on the duration. And so indeed, we will now have 2 results, right? Remember that? And if we turn these off, well, then of course it's gonna work the same. Let's just delete this empty line here. All right. And so, yeah, indeed, with our original query string, things obviously also still work the same. Alright, so we prepared our filter feature so that it ignores page and sort and limit fields. But there is actually something more that we need to do in our code in order to basically be able to implement these features in future videos. Okay, and so let's go back here to our code. And so let's now learn a little bit about how queries actually work in Mongoose. Okay, and I think I mentioned this before, but it's very important to talk about this again. So this find method here is going to return a query. Okay, so all of this here will return a query. And that is the reason why we can then chain other methods like this, like where, like equals, and yeah, so all these other methods that I talked to you about before. And let me actually show that to you in the documentation again. Okay, so here we have the query object. And again, when we use the find method, it will return an object, which is a query. Okay, and so in query.prototype, we then have all of these methods. So for example, down here, we have where, which I just mentioned. We have sort, which is the one that we're going to use later to sort. We have, let's see, we have less than or less than equal. We have greater. We have, what else did we use? We used equals. And so all of these are part of query.prototype, which again refers to objects that we're creating using the query class. All right. And so again, this is the reason why we can do this sort of chaining. And now comes the important part. So as soon as we actually await the result of the query, so as soon as we use await here, or here for example, as soon as we use this await, the query will then execute and come back with the documents that actually match our query. And so if we do it like this, such as we have here, then there's no way of later implementing sorting or pagination or all of these other features. Okay? And so instead, what we will have to do is to save this part here into a query, and then in the end, as soon as we change all the methods to the query that we need to, only then by the end we can await that query. All right? So for example, we're going to use the sort method. We're going to use the project method. We're going to use the limit method. And we're going to use really a bunch of methods and chain them to this query. And that would be impossible to do again if we await the result of this initial query here right away. Okay? So I hope that made sense. And so the way that we will do it is that we will have our tours down here, and this will await the query. And the query is, well, simply the query without any await. All right? And just to make it consistent with this part here, let's do it like this. Okay? So let's say that first we build the query and then we execute the query. All right? And that's not correct. All right. And since we're doing comments here, let's also say send response. Okay, just to make our code a bit more easy to scan. So I hope that all of this made sense. This turned out to be quite a long video, but it was important to finish this part here by explaining you this logic here, so that in the next videos we will then be able to implement the rest of the features. All right? Because again, without having it like this, it would not work. So the filter feature that we have implemented right now already works great. But in this video, we want to take it to the next level by allowing some even more complex queries. So right now, a user can only filter the documents by setting one key equal to a value, right? But now we actually also want to implement the greater than, the greater or equal than, the less than, and the less or equal than operators. All right? So instead of just having equal, we want to actually be able to, for example, say duration greater or equal than 5, and not just equal. All right? And so that makes everything a bit more complex. Now, before writing any code, I will actually do the exercise of writing out the query, how it should look like in MongoDB. Okay? So what would the filter object actually look like? And let's write it here as a comment, and again, just as an exercise. So the object would look a bit like this. So difficulty, let's start with that one, set to easy. And then duration. And now remember that when we want to use an operator, we need to start another object. And then for the greater or equal than operator, we use it like this, to 5, right? Remember that? So this is how we would manually write the filter object for the query that we just specified. Now let's actually go to back to Postman so that I can show you a very kind of standard way of writing a query string including these operators. And we do it like this. So before the equal sign, we open up the brackets, and then in here we write the operator. So in this case, greater than or equal. And that's it. And so basically like this, we add a third part to the key value pair. So we have the key, the value, and now also the operator. And we use, again, these brackets in order to specify the operator. Okay? So again, that is a standard way. And so let's now actually go ahead and take a look at the query string that Express gives us. And so just like before, let's actually log a rec.query to the console. Log rec.query. All right. And so let's take a look what our query object is going to look like when we specify the query string like this. All right. Now, the first thing that you notice is that we get an error here, but don't worry about that for now. So what I'm interested here is this object. And so let me actually go ahead and copy it here. All right. So what do you notice here? Well, what we see here is that the query object looks almost identical to the filter object that we wrote manually. The only difference is that in this one, we have the MongoDB operator sign here, right? So that's really the only thing that's missing here in front of this operator name. Okay? And so the solution for this is to basically replace all the operators like this with their correspondent MongoDB operators. So basically adding this dollar sign here. Okay? And so let's now implement that. And in fact, we do it somewhere up here. Let's actually add some more comments here. So filtering that we did in the last lecture. Now here let's add some advanced filtering. And so that's the code that we're going to write now. And let's put this code here right at the top. All right. Then this code here we don't really need, but I still want to keep it here. So let's put it just here at the end. And then just this code here as a reference, just to make sure that we know what we're doing here. All right. And so now that we know what we need to do here, it is actually just a simple JavaScript problem. And the way I'm solving it is this. So first, I'm going to convert the object to a string. So query string equals JSON.stringify of query object. Okay, and so now I can use that query string to use the replace function on it. All right, and so what I want to replace now is the GTE with $GTE, and then also some other operators. So the ones we want to replace are greater than or equal, greater than, less than or equal, and less than. And there are a couple of ways in which we could do it, but I'm going to use a regular expression. All right, and for me personally, regular expressions are one of the most difficult concepts in JavaScript and actually in general in programming. So usually when I need to do something like this, I simply go on Stack Overflow or just Google around to find the right solution for the problem that I'm trying to solve. All right. And so what we want to do now here is to basically match one of these 4 words and then replace it with the same word, but with the dollar sign in front. All right. And so the regular expression to find one of these 4 words goes like this. So we open up these parentheses and then we write the operators. So GTE or GT or LTE or LT. All right. And then we also need to add this \b before and after. And that's because we only want to match these exact words. Okay? So imagine there's a word which has like LT in it. Then we of course do not want to match that. We only want to match if it is this exact word without any other string around it. Okay? And so this regular expression that I have here will take care of that. And actually there's one piece missing, and that is this G flag here, which means that it will actually happen multiple times. So if we have like 2 or 3 operators, or even all of them, then it will replace all of them. And without this G here, it would only replace the first occurrence. Okay, so this one is very important. Now, what do we actually want to replace it with? Well, the replace method actually accepts a callback, which is very powerful, and this callback has as the first argument the matched word, or the matched string. Okay, so we can pass a match into that callback function, and what we return from this callback is the new string that will replace the old one. Okay, so let's do a template string here. And so we want to replace the match with $match. Okay, so this is here the part of the template string syntax. Okay, so this here is this match, and then we want to put the $sign in front of that. All right, okay, and now just to make sure, let's actually log it to the console. And actually we want the object back, and so json.parse the query string. All right, let me just go ahead and clear this here so that you can see the results a bit better. Okay, so again, we get this error here, and that's of course because MongoDB cannot really use the query string or the query object as we have it right now. Okay, and here we have the 2 results, and you actually see that our result is the exact same as before. And so something here is clearly not working. So let's try to figure out what that is. And here the regular expression looks just fine. Everything looks fine here. But okay, yeah, the problem is that I'm replacing it in the string, but then I'm not saving it anywhere. And so I actually want to save it back to the query string. So let's change this here to a let, so that I can then mutate the data. And so let's say query string, so query string equals the query string replaced, just like before. Okay, so what I was forgetting is simply to actually save the result here back into the variable. All right, let's try that again. And now it's working. So now we have the $sign in front of the operator. Great. Okay, so it works. Let's get rid of these comments here. And now finally, all we have to do is to actually here not use the query object, but just use this. Okay, so JSON parse query string. And of course, if we do not have any operator in the query string, then everything will work just fine. It will simply not find any of these 4 operators there, but that's no problem. It will then simply not replace anything. All right. And also let's go ahead and try this out. And it's taking a bit of time, but indeed it came back with 3 results. And so let's now check if they're actually correct. So the duration should be greater or equal than 5. And this one here has a duration of 5. This has a duration of 9, which is greater or equal than 5. And so it's actually working. The difficulty is still easy. And so what that means is that the code that we just implemented works just fine. Perfect. Now let's just, for the fun of it, add another parameter up there. So let's filter for the price now as well. And so this one has almost 2000, then 1100. This one has 300. So let's now filter for prices less than 1000 or less than 1500. Okay, so and price, and now again or brackets, and we use less than 1500. All right, send that, and what do we get here? Oh, now we only have 2 results, and indeed the price is here 397 and here 1197, and so the one before that was 2000 is now gone. And so we filtered that one out as well, using again the operator that we just implemented. And we could now filter for all kinds of stuff here, but you get the point, okay? And so, yeah, we implemented or kind of advanced filtering here at this point, which now even accepts these 4 operators. Now in the real world, we would then have to write some documentation basically in order to allow the user to know which kinds of operation they can do on our API, right? So again, ideally, we would completely document our API, specifying which requests can be made, using which HTTP methods, and then also what kind of filtering or sorting or all these features, which of them are available and how they can use it, right? Now, in our case, we of course will not do that. But again, don't forget that if you're really implementing an API that is going to be used by someone else, then you must really do this kind of documentation, all right? But anyway, let's now move on to our next video and implement a sorting functionality. Let's now implement result sorting in order to enable our users to sort the result based on a certain field. So let's now take a look at all our results here for now. All right. And so let's say that we actually want to sort these results, let's say by price. Okay, so starting with the lowest price and then moving up all the way to the highest price. All right, so we have all kinds of prices, $3.97, $4.97, $11.97, $14.97, $9.97. We have even almost 3,000 here, then $14.97, and so they're not really in order. And so let's allow the user to basically sort these results based on a field that can be passed using the query string. So let's say we want to sort by price. All right. So if we run this now, of course, nothing will happen. It will still show the exact same 9 results and in the same order, because before in the last lecture, we filtered out basically this sort field, right? And so let's now actually go ahead and use it. All right. So remember here how we created the query object and then excluded the sort field here so that it didn't pollute or filtering, right? But now we actually need it, and so let's now use it. So the third feature here is sorting, or actually, well, it's the second one, so let's just call this one 1A and 1B. All right. So let's say that if there actually is a sort, so rec.query.sort, okay, and you see it down here, and now it's gone because of this error here. But anyway, from our last request, we got, of course, this query object here. And so in there, we had this sort property. All right. And if there is a sort property, well, that means that then we want to actually sort the results based on the value. Now, one quick thing that we need to do is to change this query variable here from a constant to a normal variable, so let, okay? Because now we actually want to chain something to this query. So the new query will be query.sort. And we want to sort it by rec.query.sort. All right, because that will be the value of the field, so in this case price, and Mongoose will then automatically sort the result based on the price. And now, in case you're wondering why it works this way, so why we did this here, just remember what we talked about over the last lectures. So remember how this tour.find here is going to return a query, right? And so we store that query object here in this variable so that later on we can keep chaining more methods to it. So more of these methods that are available on all documents created through the query class. Okay, remember that? I think we talked about that in depth 2 lectures ago. So in case this is still a bit confusing to you, then just go back there, or you can also take a look at the documentation. All right, now let's actually test this out. So sort is still set to price. So let's send it now. Let's take a look at the result. And indeed, we start with the lowest price, but I think we already had that before. So we start with 397, then 497, then 997, 1197, 1497, and you see that the prices actually keep increasing. So 1997, 2997, and so yeah, indeed, they are now sorted. Okay, so we sorted them by the price in an ascending order, but we can also sort them in a descending order. And that's very simple. All we have to do is to set the minus here, so minus price, and Mongoose will then automatically sort them in the other order, so in the descending order. So let's test out that one as well. And so now we should start with, yeah, exactly, with this one. So the first one is now the highest, and the last one is the 397 one. Cool. But we can actually take it one step further, because we have many cases here which have the same price. But how are these results with the same price then ordered within them? So let's say we have this one with this price, and then this one with the same price. So why does this one here appear before the second one? The same thing with this one here maybe. Oh, actually not. So this one is just the only one with 1997. But then here again we have these two with the same price. We have, okay, they are all different. Okay, so these are all different. But we want to rank them basically according to a second criteria. So in case there is a tie, then we want to have a second field by which we can then sort where the first one is the same. So in this case, the price. So in Mongoose, that's quite easy. And let me show that to you here as a comment, for example. So in Mongoose, we would just say sort. And then right now we have the price. So we have it just like this. But then in Mongoose, all we have to do is to add another field name to the string. So for example, rating average, or I think it's ratings. Okay, and so we now want to pass this field here as well to our sort. Okay, now we cannot leave a space here in the URL, and so instead we're going to add a comma. Okay, so you want to sort first by price, and then as a second criteria, also by ratings average. Okay. And so now all we need to do is to basically replace this comma here with a space. All right. And of course, we could have even more fields by which we sort. Okay. But for now, let's just leave it like this and implement it very quickly in our code. All right. And actually, let me create a new variable here. Let's call it sort by. And so we have rect.query .sort. And what we're going to do is to now split it by the comma. So split the string by the comma. And so this will then return an array of all the strings, so all the field names. And then all we have to do is to put it back together using join. And as the join string, we use a space. All right. And so just to make sure that it's correct, console.log sort by. And then of course here we want to use that sort by variable. Okay, so let's take a look at that. And so 4.7 here, and the other one also has 4.7, all right. And so let's actually go ahead and use our API to change this ratings average here. Okay, so just as a fun experiment, let's copy this ID here, then update tour. And so let's come here to the body. And so I want to update ratings average to 4.9. Okay, let's send that. And indeed, you see that it got updated. And so now let's change that again, or let's try that again actually. And so now you see the first one still has 4.7, and this one here now has 4.9. And so they are now ordered with an ascending rating, right? And of course, we could put a minus here, and so then they should change positions, meaning that the one with 4.9 should appear first. Well, let's try that as well. And yeah, indeed. So now this one, the sports lover tour, is the one that appears first. All right, great. So it looks like it's working. Let's take a look at our results here. And yeah, indeed. And let's just take a look at what we logged here at the console. And so yeah, this is our sort by variable, which kind of looks similar to what we have here. And so that was the goal of creating this variable. Great. So that's now working. Let's get rid of this console and of this one here as well. And all right. And just to finish here, let's actually add a default one. And we do that by simply adding an else block here. So in case that the user does not specify any sort field in the URL query string, we're still gonna add a sort to the query. So query.sort, and we will then sort by the created add field. All right, and actually in a descending order so that the newest ones appear first. So minus created add. All right, give this a save. And so yeah, I think like this, we're done. Let's just turn off this option here as well. And so now we just are back to our regular URL without any query strings. And so let's take a look if this is now actually ordered by the created add. So this one here ends in 59 seconds and 30, 59 and 30 as well. And yeah, so they were all created at the exact same moment because we imported them all at the same time. All right. And so in this case, we cannot really see the effect of this piece of code that we just added here. But in case these documents were added at different times, then they would now be ordered by the date they were created. All right. So that's it for sorting. Next up, we're going to talk about limiting the fields that we want in our results. As the next feature in our API, we have field limiting. So basically, in order to allow clients to choose which fields they want to get back in the response. So for a client, it's always ideal to receive as little data as possible in order to reduce the bandwidth that is consumed with each request. And that's of course especially true when we have really data-heavy datasets, right? And so it's a very nice feature to allow the API user to only request some of the fields. So, as the third feature, we will have field limiting. And just like before, let me start by showing you how it's going to work here in Postman. So we're going to specify a field called fields, and then the name of the fields that we actually want to receive. So let's say we only want the name, the duration, the difficulty, and the price. All right. And so the implementation will actually be very similar to what we did before with sorting. So if rec.query.fields, then let's actually again create a variable for these fields here. Because just like before, Mongoose actually requests a string with the field name separated by spaces. All right. Let me actually start by writing out that part. Okay. So the query itself. So query is equal to query.select. Okay. And here, for example, it expects a string like name, then space, duration, and price, for example. Okay. And so this way, it will only select these three field names and send back the result only containing that. Okay. And actually, this operation of selecting only certain field names is called projecting. Okay. So let's now go ahead and create basically the string just like we did up there. Okay. So we start with rec.query.fields, then we split it by a comma and join it with an empty string. Or with a space, actually. Sorry. So with the space, and so that's then going to produce this exact string with this exact format. Then here, all we have to do is to use these fields. Then, just like before, I also want to add a default, so in case the user does not specify the field. Okay, so in that case, we will just actually remove something. Okay, and let me show that to you first. So down here, we always have this underscore v, which is set to 0. And Mongoose just creates these fields because it uses them internally. And we could disable them, but that's not a good practice. Again, because Mongoose actually uses them. Alright? But what we can do is to basically never send them to the client. So we can exclude them. And the way we do that is to, instead of doing underscore v like before, so like we did up here basically, we just prefix it with a minus. Okay? And minus is then not including, but excluding. So what we had before here again, with the name and duration and price, that was to include these fields in the response. But this way, with the minus, we have everything except the v field here. Okay? So we're excluding only this field. All right? So let's go ahead and test that. Send it. And let's wait for it. And yeah, indeed. So the ID is by default always included. Okay, so we cannot remove that. But besides that, we have just the name, duration, difficulty, and price. Okay, and we could, of course, also use that minus, so that exclusion here as well. So we could have everything minus the name and minus the duration, for example. So let's test that as well. And so, if you now check it, you will not see the name and not see the duration anywhere here. Great. And now just as a final test, let's see if our default works as well. Sending the response. And so now we no longer have that v variable here set to 0 in all the documents. All right, great. Now there's one last thing that I want to show you, which is that we can also exclude fields right from the schema. All right, and that can be very useful, for example, when we have sensitive data that should only be used internally. For example, stuff like passwords should never be exposed to the client, and so therefore we can exclude some fields right in the schema. So for example, we might not want the user to see when exactly each tour was created. For example, the tour might already be kind of old or something, and so let's say we want to always hide this created at field. All right, so we can go into our schema, which is in the tour model, of course, and then at created at, we simply set the select property here to false. And so now when we try to get our results, you see that it's actually no longer there. Okay? And so like this, we can basically permanently hide this from the output. Perfect. So one more feature that is actually working now. And so let's now move on right to the next one. Now, another extremely important feature of a good API is to provide pagination. So basically allowing the user to only select a certain page of our results in case we have a lot of results. So let's pretend that we have, for example, 1,000 documents in a certain collection, and we say that on each page we have 100 documents. So that would mean that we'd have 10 pages, right? So 10 times 100 is 1,000. And so based on that, how are we going to implement pagination using our query string? Well, we will use the page and the limit fields. So there will be a page field. Let's say we want page 2, and there will be a limit field. And this limit here basically means the amount of results that we want per page. And let's actually set it here only to 10. And of course, we need to correct this one here. It's not a comma, but an end. So page 2 and the limit 10. Now going back to the example of 1,000 results, if the limit is 10, so only 10 results per page, well, then we're going to have 100 pages. And in here, we are then displaying page number 2 of these 100 pages. Okay? Now, we need now a way of implementing this using Mongoose. So let's take a look at how we could do that. by going back to our code. So feature number 4, pagination. All right, and I will start by building an example query here, just like we did before. So let's say that the query is equal query. And now what kind of methods do we have in order to implement pagination? Well, the most useful one is skip. And I'm going to explain what it does in a second. So let's just put a random number here. So skip and limit. And let's put 10. And so this limit here is actually exactly the same as the limit that we define in the query string. So basically the amount of results that we want in the query. And then skip that we have here is the amount of results that should be skipped before actually querying data. All right, so again, this is just a placeholder here. Let's go back to this example that we have here. I'm just going to copy this query string here. And so let's say that the user wants page number 2 with 10 results per page. That means that results 1 to 10 are on page 1 and 11 to 20 are on page 2. Okay? And so what that means is that we want to skip 10 results before we actually start querying. Okay? So again, 1 to 10 are for page 1, and then 11 to 20 are for page 2, and so on and so forth. So 21 to 30 will be page 3, and so on and so forth. And so we need to skip 10 results in order to get to result number 11, right? So to result number 11, which will be the first one on page 2. Okay, and since it is page 2 that was requested, well, again, we need to skip 10 results before we actually start page 2. Okay, makes sense? And for example, if we requested page number 3, well, then of course 20 results would first have to be skipped. And so we will need some way of calculating this skip value here. So based basically on the page and the limit. Now you might ask why I do not directly ask for the skip value in the query string, but that's because for the user, this value here is kind of abstract. Okay, it's way easier to simply say, well, I want page number 1, or I want page number 5, or I want like page number 10. Okay, so for the user, it's much easier to not deal with skip values here and all that stuff. The user wants to have it easy and to just define a page. Now, before we can actually get started calculating the skip value, we need to first get the page and the limit from the query string, and we should also define some default values. Okay, and so that's basically because we still want to have pagination even if the user does not specify any page or any limit. Because, for example, let's say that we have 1 million results in our database, and then of course, when the user does the request, we want not simply show all of these 10 million results. So that wouldn't be very user-friendly, would it? And so I will define by default page number 1 and a limit of, let's say, 100. So that by default, when a user requests all of the tours, in this example, then he only gets 100 and not 1 million. All right. So the page is, of course, request.query.page. And I'm now going to multiply it by 1, which is just a nice trick to convert a string to a number. Okay, so maybe you noticed before that each time that we actually put a number in a query string, it will then be a string in our query object. And so we need to fix that simply by multiplying by 1. Okay, and then by default, we want page number 1. All right, and so this is a nice way in JavaScript of basically defining default values. And I'm sure you're familiar with that, right? Anyway, the limit is on rec.query.limit times 1 again to convert it, or the default of 100 that we just mentioned. So ideally, the user will only specify the page number that he requests and not even bother with the page limit. That's for more specific use cases. Okay, and now all we need to do is to then define, so to calculate basically that skip value that we just talked about here before. And the best way of doing that is to go back to an example. So again, let's say we are requesting page number 3 with the limit of 10. And we see here that for page number 3, the results are from 21 to 30. So it starts at result number 21, meaning that we need to skip 20 results. And 20 results is basically 2 times 10. So 2 times this limit. Okay? And from there, we actually start getting a formula. So 2 times 10 is basically 3 minus 1 times 10. And 3 is the page that we're on. And so that is our formula. So page minus 1, and so the previous page basically, times the limit. Okay? So I hope that made sense. Let's now replace these values here. Skip and limit of limit. Okay? So basically, this number here is all the results that come before the page that we're actually requesting now. So again, if we are requesting page number 3, our results are going to start at page number 21. And so we want to skip 20 results before that. And so 20 results is because we have 2 pages times 10 results on each. And so, yeah, it's going to be the page that we just requested. So page here minus 1, so the previous page, times the number of results on each page. Okay, so that's the amount of documents that are going to be skipped. Okay, so I hope that made sense. Let's now go ahead and actually try this. And since we only have so few results here, we need to test it with a really small limit. So let's say that we only want 3 results per page, and let's actually start on page number 1. So let's send it, and indeed, now we only get 3 results, as you can see here. So these 3, let's see, so the Forest Hiker, the Sea Explorer, and the City Wanderer. Okay, let's try page number 2. And for some reason, Postman keeps jumping around each time that I change the URL. Anyway, now we have the Park Camper, the Snow Adventurer, and the Sports Lover. And so you start seeing that we actually now have different tours. Okay, and so we can kind of say that our pagination here is already working. So now the last page, and we have now the Northern Lights, the Wine Taster, and the Stargazer. All right. Now, what if we try to go to page number 4? We already know that we only have 9 tours. And so on page number 4, there should be nothing, right? So let's test that. And indeed, we get 0 results. But that is, of course, not ideal. Okay, and so let's now go ahead and fix that and basically kind of throw an error each time that the user selects a page that does not exist. Because that's basically the situation here. The user requested a page that simply does not exist. We don't have enough results to have 4 pages with 3 results. So let's now do that. And this will actually only happen when there is a page on the query. And so let's actually create this if statement here. So if request.query.page, only in this case we will test if we are skipping more tours than we actually have. So let's get the amount of tours. So number of tours is equal to, and now we're actually going to learn a new method. So a new method that is on the tour model, which is called count documents. Okay, and as the name says, this is going to return the number of documents. All right, now actually it's going to return a promise, but we then await the promise, and so it will then come back with the result of the amount of tours. Okay, and so if the number of documents that we skip is greater than the number of documents that actually exists, well, then that means that the page does not exist. All right, that makes sense? So if skip is greater than the number of tours, and for now what I'm going to do here is to throw a new error. Okay, so throw a new error. This page does not exist. Now, why am I throwing an error here? Well, simply because if I throw an error here in the try block, which we are currently in, it will then automatically and immediately move on to the catch block. And it will then send back this 404 kind of fail message, okay? And so that's what we want for now. Just keep in mind that we will implement much better error handling a bit later in the course, and actually right in the next section, okay? But for now, let's just keep it simple, throw this error here, in case that we're trying to skip more documents that we actually have. Okay. So this is the right case. Let's send it here. And that's not the result that I expected. So let's go back. So right now, our page is 4 and the limit is 3. So the skip here would be 3 times 3, so 9, okay? And the number of tours is 9 as well. And so skip is not greater than the number of tours, and therefore we don't get this error. So what we need to do is to set it to greater or equal. Okay, and so that should now work. And that takes a long time. And indeed, now we get the fail status here and the 404. For some reason, this error is not showing up here, which it actually should. Oh, but don't worry about that. That's not really important. What matters is that it did actually enter our catch block and then send back this 404 response. Everything else we're going to implement a bit later. Okay, and that's actually it. So that's all the methods that we're going to add to our query. And so when we finally reach the next line of code here, our query will then be awaited and return with the tours. Okay, and at this point, our query might actually look something like this, something like, well, what do we have here? We have sort, select. So we might have sort, and then some select there. We have also skip. We have limit as well. And so that's a really kind of a big query. And again, what allows us to do that is that each of these methods here will always return a new query that we can then chain on the next method and the next method and the next method until we finally await the query so that it can actually give us our documents. Okay, so let's get rid of all these comments. And yeah, that's it for now for these features. We're just going to add one more in the next lecture, but that one is going to be a bit different than these. It's not going to use one of these query methods. All right, so I hope that over the last couple of lectures, you really learned the ins and outs of querying data with Mongoose. So of course, all of these methods that we used are not only useful for these features that we implemented here. You can really create all kinds of queries that you can imagine for all kinds of applications. So I showed you all the techniques here in this context of these different API features, but of course, you're going to be able to use them all over your applications in the future. Okay? So I hope that was fun for you, and if it was, then let's move on now right to the next one. See you! Another nice small feature that we can add to an API is to provide an alias route to a request that might be very popular, so that might be requested all the time. And for example, we might want to provide a route specifically for the 5 best cheap tours, okay? So if we'd use our regular route here with the filters and with all the features that we already have, the request would look a little bit like this. So let's get rid of all of this. So the 5 best and cheapest tours. So that means we have a limit of 5, right? And then we're going to sort by ratings and by price. Okay, so sort, and then the average rating and descending. So minus ratings average. And in case they have the same average, then we want the cheapest price possible. And so we're going to sort also by price. Okay, so let's quickly take a look at the results. And indeed, we get 5 tours here. And Postman does this scrolling again. So we have tours with 4.9, 4.9, 4.9 again, 4.8, and 4.7. Okay, and so these are actually our 5 best and cheapest tours. If we said cheapest and best, well then maybe we would have to sort by price first, because some of them are not really cheap. For example, this one. Okay, but we selected first the average. Okay, and so we sorted by the highest average first, and only then, in case of a tie, basically only then by the price. All right. Now let's say that this is a request that is done all the time, and we want to provide a route that is simple and easy to memorize for the user. Okay, so let's go to our app and try to implement that. And we're going to start at the routes, so to a router, and we then need to create a new route. And let's do that here right at the top. So router dot route. And so how are we going to call this route? Well, let's say top 5 cheap. All right. So quite a simple name, but it's going to work. And then we actually only want get requests to this route. Okay, and so now it's time to think. How are we going to implement this functionality? Well, in essence, what we want is to actually still get all the tours, just like here. And so let me go ahead and start by copying and pasting that here. So we really still want to use this function here, because it doesn't really make sense to rewrite all of the logic that is in there. But before we can call this route handler, we basically want to prefill some of the fields in the query string, right? So we already know that our query string should look like this. And actually we can add some more stuff here. But in essence, our query string has to look something like this. And so the solution is going to be to run a middleware before we actually run this getAllTours handler. Okay? And so that middleware function is then going to manipulate the query object that's coming in. All right? And so this is yet another really nice example of using middleware, because you really need to get familiar and used to this concept of using middleware strategically in order to change the request object as we need it. Okay, so let's add it here then. So to our controller, and then the middleware function that we're going to create in a second, which is going to be called alias top tours. Okay, so let's copy that name, move to the tour controller, and I'm going to put it here at the very top. So exports dot then request response. And what's the third argument that we need in the middleware? Remember? And I know the express section is kind of far away already at this point, but I hope you remember that the third argument here needs to be next. So in order to call the next middleware that's in the middleware stack. All right. All right, give it a save. And so this error there should disappear. Okay, and so let's do what we said we would do. So basically to manipulate the query object so that when it reaches the getAllTours handler, it's then already different. Okay, so let's first do that and then really take a look at what happens. So remember, the limit is going to be set to 5. And remember that everything is strings here, and so I'm setting this also to a string. Okay, now what else did we have? So we have this sort. So let's just copy this here and say request.query.sort should be this. And then we can actually also specify some fields so that the user doesn't get all of the fields that we have in there. So let's say that we only want the name, the price, the ratings average, the summary, and the difficulty. All right, give it a save, and now all we need is next. All right, otherwise this middleware will be stuck here forever and cannot move on. Okay, so let's now figure out a bit better what's actually going to happen here. So as soon as someone hits the top 5 cheap route, we will start. The first middleware that's going to be run is alias top tours. So the function that we just created. Okay. So what this is going to do is that it will set these properties of the query object to these values that we specified here, basically pre-filling parts of the query object before we then reach the getAllTours handler. All right, and so as soon as we then get to this function, the query object is already pre-filled, even if the user didn't put any of these parameters in the query string. All right, and so in essence, what we're doing here is to pre-filling the query string for the user so that the user doesn't have to do it on his own. Okay, and so let's now actually go ahead and try this. So I'm copying this. And here it's not tours, it is top 5 tours. Whoa, what's going on here? For some reason it doesn't find this route. So let's go back. So top 5 tours. And so here in a route, okay, it's called top 5 cheap. So my mistake here. So cheap, send it now. And that's still not correct. Yeah, of course. I still have to put the tours here, of course. So we are in the tours resource, and the whole router is mounted onto this tours route. Remember that. And so it's in that tours, a kind of mini application, remember that, where I created this top 5 cheap route. So let's hope it works now, and indeed it does. Okay, so that worked. That's fantastic. Now, of course, we could do a lot more alias routes here, but that's not really necessary. I really just wanted to show you the concept, show you that it can be a nice feature to add to any API, and also I wanted to again show you the power of middlewares. All right, so we're talking about Mongoose here, but still it's very important to keep getting familiar with the Express concept that we talked about before. All right. Anyway, we're now done with our API features. In the next video, we're just gonna quickly refactor all of this to make the entire code a bit more modular and, of course, better. All right? In this video, I want to very quickly refactor the API features that we've implemented over the last couple of lectures. Now, this is not only to make our code a bit cleaner, it's also to make it more modular and more reusable in the future. So right now, we have all this code for the features that we built before in this getAllTours function, right? And this looks a bit messy. It's a bit hard to understand, okay? And also imagine that we wanted to use these same features for another resource, for example, for the users or later for the reviews. It would be not very practical to basically copy the code from here and use it then in the other resources, right? And so what I'm going to do is to now create a class in which I'm going to add one method for each of these API features, or functionalities, as you might call them as well, all right? So let's go ahead and do that here. And I'm going to do it here for now, and then later on, I'm actually going to export it to its own file, basically to create a reusable module that we can later on import into other controllers. All right. So class, and I'm calling it API features. All right. Then we start with our constructor function. And remember that this is a function that gets automatically called as soon as we create a new object out of this class. All right. Now, what do I actually want in these API features? Actually, I'm only going to pass in 2 variables here. Okay. So the Mongoose query and also the query string that we get from Express. So basically coming from the route. All right. So that's what we usually have access to in rec.query. Okay. Now again, I'm passing the query here because I do not want to query inside of this class, because that would then bound this class to the tour resource. But again, I want this to be as reusable as possible. All right. So what we usually do in this constructor function is to say this dot query equals the query that we got as an argument, and then this dot query string is equal to the query string. Okay. So very simple, very typical constructor function. And now, as I mentioned, I'm going to create one method for each of the functionality, starting with filter. All right, and so let's now go ahead and cut the code from here, or actually I'm going to copy it and then comment it so that I don't do any accidental damage. So copy and then comment and put it right here. So a couple of things that we need to change. First on, request.query is not going to be available inside of this class. And so that's why we actually passed in the query string. And so this here is going to get replaced with this dot query string. Okay, so again, this is just basic JavaScript, has actually nothing to do with Node or Express at all. Then the rest here is okay, but this here is not okay at all. So I do not want to query the tour directly here, remember, but instead I simply want to now add this find to the query that we already have. So this dot query dot find, and so that will then be this. All right, let's now get rid of this. And before we add any more methods here, let's actually go ahead and use this class just so this makes more sense to you. Okay, so how is this actually gonna work? And I'm gonna do it all here at the end, here under execute query. All right, and so what I can do now is to create a variable called features, for example. And then from here, I will create a new API features object. Okay, so basically creating an instance of this API features that will then get stored into features. And this here will then have access to all the methods that we're going to define in the class definition. Okay, so remember in here we need to pass a query and the query string. So the query, how do we create one? Remember it's tour.find. So there's a query object, and so that's the one that we pass into this class. And then of course the query string, which is rec.query. Okay, now on these features here, remember we have now access to filter. And so let's actually put it right here afterwards. So dot filter, give it a save. And so just like this, we're going to run our code for the API filtering functionality. Then here, the next line is of course also not going to work because this query here does not anymore exist. Instead, what we have now is features.query. Right? So after all this processing here, basically, okay, so right now after this filter, this .query will then have this new find method on it. Okay, and so again, this is then stored in this .query. And later on, we will have all these other methods, which all of them will manipulate this .query. So that in the end, this .query is the query that we want to execute. So just like here. Okay, so just like here, we always kept manipulating the query variable. We kept adding more and more methods to it until we then executed it by the end. And so here, we're doing exactly the same. We are simply moving the code into all of these methods. Okay, then in the end, as I said, the query is going to be stored inside of this property here. And so, yeah, that's where we then do the await and get back the results. All right. Anyway, let's keep moving here and implement the sorting. So I'm copying and commenting. So filter. And the next one is called sort. All right. And so here again, we need to replace request.query with this .query string. Okay. And then query is now this .query. So let's get these four and this .query. Okay. Now the goal here is to basically chain these methods here one after another. So let me show that to you here. So we have filter, and then after that, we want to chain the sort method. Now, right now, that is not really going to work, because where are we actually chaining this sort on? So basically, we're trying to call it on the result of this. But right now, what is the result of this? Well, it's not really anything, because this filter method here doesn't return anything, right? Now, this piece of code here, of course, returned the object that has just been created. And so then we can chain the filter method on that. But the filter method in turn does not return anything. And so at this point, we cannot really then call a sort on the object, right? And so the simple solution to that, and maybe you've done that earlier sometime in your code, is that we have to now return this. So return this, and this is simply the entire object, okay? And the same then down here. So return this. In order to, again, return the entire object, which of course then has access to these other methods, so that we can then call them there. All right. So next up is the limiting. And I'm going to call this one limit fields. And that's because all of these methods have these verbs as names. So it's filter, sort, limit, and then paginate is going to be the next one. So again, rec.query, it's now this.queryString, and query here is now this.query. All right. Return this, and this is not correct. Okay. And finally, the pagination. Copy, comment. So paginate, return this, and of course we need to replace these rec.query, this.query string, and then here, just like before, it's going to be this.query. And I just realized that up there, right in the first method, we didn't do this here. So we simply said this.query and then added the find there. But then, of course, we need to actually save it into this query property. Okay, and so I forgot that. And we get some error here. All right, that doesn't really matter here at this moment. Or actually it does, because this line of code here is actually in our paginate method. So let's go there. And in fact, I actually wanted to talk to you about this here. Because if you think about it, requesting the next page, which has 0 result, is not really an error. The fact that there are no results is enough for the user to realize that basically the page that was requested doesn't contain any data. So we do not really need an error in the situation. And so I'm just going to go ahead and delete all this code. Okay. So let me save it now here. And so now, of course, the error is gone. And here we also still have to keep adding these other methods. So limit fields and dot paginate. Give it a save. And again, remember that all of this chaining here only works because after calling each of these methods, we always return this. And this is the object itself, which has access to each of these methods here, making it possible to chain them just like we have it here. Okay, so just to recap, we are creating a new object of the API features class. In there, we are passing a query object and the query string that's coming from Express. Okay? Then, in each of these 4 methods here that we call one after another, we basically manipulate the query. We keep adding more methods to it, just like we've been doing up here before we did any of this refactoring, right? So we keep adding stuff to the query here until the end, and then by the end, we simply await the result of that query so that it can come back with all the documents that were selected, okay? And that query now lives at features, which is this object here, so features.query. Okay, I hope that makes sense. So before we do anything else, let's go back to Postman and actually try it out. And we can try it out right here with this top 5 cheap route, because that actually behind the scenes uses all of these API features, right? So if I send it, well, it still works. So that's fantastic. So let's close it. And let me actually also save it here. So get top 5 cheap tours. And yeah, I'm going to leave it there at the end. And now just here, let's do some testing. For example, remove this sort. Let me leave the limit, difficulty, duration, price. So I'm going to leave all of this here just to see if it still works. And it looks like everything is still working, right? So these are the exact same results that we got before or refactoring. So great, perfect, that worked. And so let's now actually delete all this code from here, which makes our route handler so much cleaner, doesn't it? So that's so much better, really. It's day and night, okay? Now the next step is to actually go ahead and take all this code, cut it, and put it into a new file. So a new module, basically, okay? And for that, I'm going to create a new folder here, which I'm going to call utils. So that stands basically for utilities. And I'm going to add a couple of stuff in here over the rest of the course. Okay, so this one is going to be called API features.js and with a capital F here. All right, so here goes our class. And in the end, we do a module.export of this class. So nothing new at this point. Give it a save, close it, and now in here we can require it. So const API features, then require. Then we need to move one folder up, then into utils and API features. Okay, one more test. And taking some time, and here we go. Beautiful. That's really just beautiful. Now, if we create another resource, again, for example, for the users, it's going to be so easy to drop in this same functionality. All we're going to have to do is to require this file and then basically do the same as here. Or maybe in that case, we don't even want to have the sorting ability, or we don't want to have the filter ability. And then all we have to do is to simply take out this line of code, and then like magic, it will only do these 3 functionalities, or these 3 features, okay? And so that's really great. I hope you can see the value of this, and yeah, I'm really happy with this result. Welcome back. In this video and the next one, I want to introduce you to the MongoDB aggregation pipeline, which is an extremely powerful and extremely useful MongoDB framework for data aggregation. And the idea is that we basically define a pipeline that all the documents from a certain collection go through, where they are processed step by step in order to transform them into aggregated results. For example, we can use the aggregation pipeline in order to calculate averages, or calculating minimum and maximum values. We can calculate distances even, and we can really do all kinds of stuff. It's really amazing how powerful this aggregation pipeline is. All right, but enough talk. Let's now actually start using the aggregation pipeline, and I'm going to create a new handler function here. Okay, because later on we will then define a new route and then use that function for that. But that new route, I'm going to create it later. Okay, so I want to create a function here that's going to calculate a couple of statistics about our tours. All right, so I'm going to call this one get tour stats. Okay, so stats for statistics, and it's going to be an async function. And so VS Code now automatically pre-filled all of this. All right, let's create our try catch block here. And actually, I'm going to copy this from right up here. And now in here, I will create a variable called stats. All right. Now, the aggregation pipeline really is a MongoDB feature, but Mongoose, of course, gives us access to it so that we can use it in the Mongoose driver, right? So using our tour model in order to access the tour collection, we say tour.aggregate. All right. And so the aggregation pipeline is a bit like a regular query. And so using the aggregation pipeline is just a bit like doing a regular query, all right? The difference here is that in aggregations, as I already mentioned, we can manipulate the data in a couple of different steps. And so let's now actually define these steps. And for that, we pass in an array of so-called stages, all right? So we pass in an array, and in here, we will then have a lot of stages. And again, the documents then pass through these stages one by one, step by step, in the defined sequence as we define it here. Okay? So each of the elements in this array will be one of the stages. And there are a ton of different stages that we can choose from, but I will just show you the most common ones in this lecture and also in the next one. But anyway, I now want to take a minute and take a quick look at the MongoDB documentation, because I think we didn't do that yet. All right. So MongoDB, and we already know this website. So on our MongoDB website, we go here to Learn, then Documentation, and then in here we select the MongoDB manual. And this documentation is huge. It has a lot of stuff in here. And if you were going to go through it all, well, then you'd become really a MongoDB master. All right. So it gives you a nice introduction to MongoDB. You have the installation here. You have the CRUD operations. So a nice overview about a lot of the stuff that we already learned before, right? Then you have stuff about the aggregation, and in particular, the aggregation pipeline, which we're going to talk about now. But what I want to really show you here is actually this reference that we have at the bottom. Because in the reference, we have here, for example, the operators. And that's where we have a lot of important stuff that we've been using all the time. So let's take a look here at the query operators, for example. And here you see, we actually have these operators that we already used. So for example, greater than or equal, or less than and equal. But if someday in your own applications you need some other operator, well, now you know where you can find them. Now, of course, it's also always very helpful to just do a quick Google search, probably find some Stack Overflow post about it. But believe me, many times it's easier and faster to just quickly jump into the documentation and quickly search for whatever you're needing. Okay? You just need to know how the documentation works, and once you know that, it's then going to be quite easy for you to find what you're looking for. All right? Here you also have some logical operators. For example, the OR operator we already used again. And yeah, really a lot of stuff. Geospatial operators. And we're going to use some actually later. And yeah, really a lot of stuff. Then what I wanted to show you for this lecture actually are the aggregation pipeline stages. Okay, so here you have a lot of them. And what we're going to use in this lecture here is match, for example, and group. Where is that? Yeah, group. That is a very important one. And so, as I mentioned, I'm going to show you the most important ones in this lecture and the next one. But again, if you, in some case, need something else, then just go ahead, come here to this documentation, and you will find what you're looking for. All right? Anyway, let's now learn how we can actually define one of these stages. All right? And I'm going to start with match. And match is basically to select or to filter certain documents. And so it's very simple. It's really just like a filter object in MongoDB, such like we've been using so many times. So each of the stages is an object, and then here comes the name of the stage. So this one is the match stage. All right. And as I mentioned, it's really just a query. Okay. And so let's say that for starters, we only want to select documents which have a ratings average greater or equal than 4.5. So can you do that? I'm just going to give you a second to do that here. All right. So I hope you did it. So ratings average should be greater or equal than 4.5. Okay, and so that's it. That's the first stage. And usually this match stage is just a preliminary stage to then prepare for the next stages which come ahead. So the next one is now the group stage. So group, and then in there we need to always pass just another object. So it looks kind of weird with all these objects, but yeah, you've seen that before, and MongoDB just works this way. It's always objects inside of objects inside of objects, all right? And this group here is where the real magic happens, because as the name says, it allows us to group documents together basically using accumulators. And an accumulator is, for example, even calculating an average. So if we have 5 tours, each of them has a rating, we can then calculate the average rating using group. Okay, and so let's do exactly that right here. Now the first thing that we need to always specify is the ID, because this is where we're going to specify what we want to group by. Alright, now for now we say null here because we want to have everything in one group so that we can calculate the statistics for all of the tours together and not separated by groups. Okay, we will a bit later then also group by different stuff. For example, we can group by the difficulty, and we can then, for example, calculate the average for the easy tours, the average for the medium tours, and the average for the difficult tours. Okay, so again, we can group by one of our fields, and that field we are gonna specify in here. But for now, as I said, we want to calculate these averages for all the tours together in one big group. All right. And so in that case, we say underscore ID and set it to null. Okay, and now let's actually calculate the average rating. In order to do that, we simply specify a new field. So let's simply call it the average rating. All right, so like this. And this will be, well, the average, which is yet another MongoDB operator. So this one here, and you will find it in the reference if you look it up, okay? So this is a mathematical operator calculating the average and now the name of the field. And again, I know that this is going to look very weird, but in order to specify the field which we want to calculate the average from, we need to use the $, but in quotes here, and then the name of the field. So ratings average in this case. Okay. And let's also calculate the average price. So average price, and again, did it wrong here. And so the average, and then again, the name of the field, and in quotes, and with this $. Right, so it looks kind of weird again, but this is just the way that the aggregation pipeline works. So we have the average price. Let's actually also calculate the minimum price, so the smallest price, and the largest price. So min price, and from now on it's gonna all look kind of similar. So now we use the min operator, and then again the field name like this. All right, and a comma here, and let's now just duplicate this one in order to calculate the maximum price. Okay, and now let's actually take a look at what we already got at this point. Okay, so we now need to actually send out this response. And so again, I'm just gonna go ahead and grab some of these already done responses here. Okay, so the data that we want to send out is called stats. Stats. Okay. And now all we need to do is to actually add a new route here in our tour routes. And again, I'm going to add that here right at the top. So router.route /get tour, or actually just tour stats, just like this. Okay, because the get is already defined in the HTTP method. So no need to repeat it in the name. So tour controller dot get tour stats. Give it a save, and let's actually test it out now. So I'm really excited to test it out now, actually, to see if it works, because again, it's really an amazing and really powerful tool which allows you to do so much stuff. So tour stats, send it, and that's not really the result that we were waiting for. So that's just the pipeline that we defined, but I already know why that is. So we did not await the result. So this basically, just like a normal query, is going to return an aggregate object. Okay, so .find is going to return a query, and .aggregate is going to return an aggregate object. And then only when we await it, it actually comes back with the result. So that's also why we defined this function here as an async function, so that we can then use await in there. And so this is the right place. Let's try it again. And here we go. So great. We have the average rating of all our tours. We have the average price, which you see is 1,563, and then the minimum and the maximum, right? And from our data, we can actually confirm that this is true. So great, really, really great. Now, one more thing that I want to do here is to actually calculate the total number of ratings that we have and also the total number of tours. So we have the average rating here, and let's actually do it before. So num of ratings, just like this. And you can probably guess that this one is called sum, and then the ratings average. Or actually not ratings average, but ratings quantity, right? So that's where the number of ratings is stored. And so the number of ratings, the total, will be the sum of all of these together. And now the last one is the number of tours. And that one is a bit trickier. And so that's a nice one to show you here. So we still want to sum, so to add everything together basically. So we still use sum, but what are we going to add together? Well, we basically add 1 for each document. And so we say 1, and that's it. So basically, for each of the document that's going to go through this pipeline, 1 will be added to this num counter. Let's call it num tours. Okay. And so, yeah, let's test it out now again. And indeed, we get our 9 tours, and we already know that we have 9. Okay, so these are all the statistics for all the tours together. But let's now take it to the next level. As I said before, we can now group our results for different fields. And let's actually start out with the difficulty. And so that's quite similar to specifying the fields down there, which is simply the $ and then the name of the field. So difficulty, give it a save, and that's it. Send it here, and now we have the statistics all defined for each of these 3 difficulties. So that's really, really amazing. So this is the part that blows my mind. It's absolutely fantastic. I mean, you can start to see all the kinds of stuff, all the kinds of data manipulation that you can do using this pipeline, right? So we really can now start to analyze stuff. For example, we see that the easiest tours are the ones who get the poorest ratings with a 4.6, while the medium tours are the ones who get the highest ratings. We can also see that the difficult tours are the most expensive ones with an average price of $19.97, while the easiest ones are also the cheapest ones with a price of $1,272, right? We also see that the easiest tours are the ones which we have the most, so 4 easy ones and only 2 difficult ones, right? So we can use this, of course, to get all kinds of insights into our data. Okay, let's comment this one out here, and let's just try another one. For example, by ratings. Why not? Let's just try it out, see what we get. So for example, we have 2 tours, so basically with a rating of 4.5. We have 2 tours with 4.7, 1 tour with 4.8, and 3 tours with 4.9. Oh, and also down here, 1 tour with 4.6. And so, for example, one insight that we can get here is that the very expensive tours with this average price of $19.97 get extremely good ratings. So all kinds of stuff really that we can do here. Let's get rid of this one. Let's add this one back. And we can now actually even do some operations with this one. So just for fun, let's put this difficulty to uppercase. So there is of course going to be another object here. And then here in front is the operator. And so the operator in this case is called toUpper. So just yet another MongoDB operator. So check it out. And now it's spelled uppercase. Great. So we have the group stage here, which is quite complete. So let's try another one, which is the sort stage. So another object in our array for yet another stage. And this one is called sort. So sort, and then in there we need yet another object. And it kind of auto-completed this one, I don't know why. And so here we can now specify which field we want to sort this by. And let's actually use the average price. Okay, and now here in the sorting, we actually need to use the field names that we specified up here in the group, right? We can no longer use the old names because at this point they are already gone. They no longer exist. So at this point in the aggregation pipeline, we really already have these results. So these are now our documents basically. And so if we want to sort by the average price, then this is the field name that we gotta use. So we can say the average price, and then we can say 1 for ascending. So let's try that out. And yeah, indeed. So that's the lowest one, and that's the highest one. Great. So we did a lot of stuff. Let me just show you that we can also repeat stages. So let's actually do another match here. And this one is really just to show you that we actually can repeat stages. And I also want to show you another operator. So let's now select by ID. And remember that ID is now the difficulty, right? So we just specify that up here. Okay, so we want the ID. And now a new operator that we didn't use yet. We want it to be not equal to, and let's say easy. Okay. And so just like this, we're going to select all the documents that are not easy. So in this case, the one that says medium and difficult, right? So basically excluding the one that says easy, right? So again, it's not really useful here because that will take away a lot of our meaningful data. But just to show you that we can, of course, match multiple times. So in this case, we matched once before we actually did the group. And then we matched once we were ready doing the grouping. All right. Now let's actually keep this here out of our aggregation pipeline, but I'm gonna leave it here just so that you keep it as a reference. All right. Give it another save, give it another try. And so these are our results for getting our tour statistics. So really nice, really great. I hope you enjoyed this video. And in the next one, we're actually going to keep using the aggregation pipeline to do some more calculations and to show you some more different stages. So keep tuned for that one. Hey there! So in this video, we're going to keep working with the aggregation pipeline. And I really love this video because in this one, we're going to solve a real business problem. So let's imagine that we are really developing this application for the Nature's company. And so let's say that they ask us to implement a function to calculate the busiest month of a given year. So basically by calculating how many tours start in each of the month of the given year. And the company really needs this function to prepare accordingly for these tours, like to hire tour guides or to buy the equipment and all stuff like that. And so this is a real business problem that we now can solve using aggregation pipelines. Okay, and so this is going to be a real challenge, and I hope it's going to be really fun to solve this kind of real business need, at least if Nader's was a real business, I guess. So let's start by, again, creating the function. So exports dot, and I'm going to call it get monthly plan. All right. And again, it's going to be an async function. And then request response or try catch block. And I could actually just have gone and copied it from up here, but never mind. All right. And now let's actually also implement the route right here. And I'm just going to duplicate this line. So monthly plan. And then here, this one is called get monthly plan. And actually, we want to be able to pass a year in the URL. And so let's use a URL parameter for that. All right. So coming back here, let's start by defining the year. So the year is coming from rec.params.year. Remember that. And then again, that trick to transform it into a number. Okay. Then I'm going to create the plan variable, which is going to await tour.aggregate. So just like before. And for now, I'm going to leave it empty here. And I will copy this piece of code to then send the result. This one is called plan. And all right. So now we're ready to start our aggregation pipeline just like we did in the last video. Now to start, let's actually take a look at the complete result just so we can get a better idea of what we actually need to build here. So let's do get all tours and get completely rid of this query string. And so here we have our 9 tours, and each of the tours, remember, has an array of these start dates. So one tour will start on April 25th, 2021. Then the next one starts on July 20th and then October 5th. All right. Then the next one has these start dates, and all of them, I believe, have 3 starting dates. Okay. And so these dates is what we actually need as a starting point to create this function or to create this aggregation pipeline. Because remember, we want to count how many tours there are for each of the month in a given year. And so let's say that we're analyzing 2021. Okay, so we have 1 tour in April, 1 in July, 1 in October. Then let's take a look at the next tour. Here we have 1 in June, 1 in July, and 1 in August. And so in July, we already have 2. So this one and this one. Next one, we have 1 in March, 1 in May, and 1 in June. And so in June, we also already have 2. Okay, and so we can keep going and doing it manually, but of course, we want to do it with our aggregation. So if we want to add all of this together, the easiest way would basically be to have 1 tour for each of these dates here, right? And we can actually do that using the aggregation pipeline. There is a stage for doing exactly that, and that is called unwind. So let's use it now, and I will then show you the result of it and why we really need it. Okay, so again, we define an object and then the name of the stage. And in this case, it is unwind. Okay, and what unwind is going to do is to basically deconstruct an array field from the input documents and then output 1 document for each element of the array. And so that's what I was saying before, which is that basically we want to have 1 tour for each of these dates in the array. Okay, and this stage can be really useful for so many cases. So the field with the array that we want to unwind is start dates. All right, and so for now, that's actually all. So I just want to show you the result of that right now. And I think we actually already have everything in place for this to work. So just keep in mind that the route is called monthly plan and then with a year, which for now is not going to have any result, but yeah, we have to define it anyway. So monthly plan and the year of 2021. So let's send this now. And indeed, we now have the start dates no longer as an array, but only this first element of the array that we had before. So let's put them side by side. And so you see, we had, or actually let's do it with the first one. So we had the forest hiker for April 25th, July 20, and October 5th. And so now we have the forest hiker on this date here. Then we have the forest hiker on July 20, and now we will have the forest hiker for October 5th. So exactly the result that we wanted, because now we have one document for each of the dates. Okay, so instead of having 9, we now have 27, which is 9 times 3. All right, so that's the first stage. Now let's actually go ahead and select the document for the year that was passed in. Okay, and remember which stage we use for that? That's right, we use match. So remember, match is basically to select documents. So just to do a query. And so the year is in the start date. And so start dates is the one that we're going to search for. So start dates. And now what do we want? Well, we want the date basically to be greater than January 1st of the current year. So let's say 2021. And we want it to be less than January 1st of 2022. Right? So basically, we want it to be between 2020 and 2022. All right? And so let's put that in code now. So start dates, and then we need another object for the operators. So greater or equal than, and in MongoDB, this works perfectly fine with dates. So Mongo is actually perfect for working with dates, like doing date comparisons. So it works really great. So now we actually need to define a new date here, so that one can then be compared with the date that's in each of the documents. So the format of the date is year, month, and day. And so let's do a template string here and use our year variable. So January 1st. So we want our date to be greater or equal than January 1st, 2021. And let's actually write that here just to keep it in mind. And we want it to be less than, or we can say less than equal. Let's go ahead and copy this one. And then December 31st. Okay, so basically we want it to be between the first day of the year and the last day of the current year. Okay, so let's keep testing it. So I will test it now after each of the stages. So sending it. And so now we should have only tours here that are in 2021. So let's confirm that 2021, here as well, here as well, here as well. So you see, we really have no other year, right? It's always 2021. Okay, so I think we've seen enough. And so let's go back. Next up is where the magic happens. And so that is usually in the group stage. So let's add the group here. So just like before. So group. And remember, we need to specify the ID field, basically to say what we want to use to group our documents. Now, we want to group them by the month, right? But currently, we simply have the entire date with the year, the month, the day, and even the hour. So I guess it's 10 in the morning or something. But again, we only want the month. And so let me show you just another like magical MongoDB operator. So where is that? So here in this back in this reference here, we actually have a couple of aggregation pipeline operators. And it's in here where we have this really handy date operator. So let's take a look at these. And the one that we're going to use is month. So it returns the month for a date as a number. Okay, and so this will basically extract the month out of our date. And there are lots of other operators like this. For example, we could even calculate the week or just a year. Okay, but the week could also be very handy. But let's keep it with a month. All right. So again, you can take a look at these special aggregation operators because there are a ton of them, as you can see here. Okay. So actually, these operators that we're using here in the aggregation pipeline are, exactly that. They are aggregation pipeline operators. We have stages and then operators that we can use. Okay. And in this case, again, we use the month. And then again, the name of the field where we want to basically extract the date from. All right, give it a save, and then that error disappears. Okay, so we are grouping it now by the month. And now the real information that we want for each of the month is how many tours start in that month, right? And for that, all we're gonna do is to basically count the amount of tours that have a certain month, right? So num of tour starts. And so this one is actually very similar to what we did before. So we use add, and then for each of the documents, we add 1. So just like we did before. But actually it is sum and not add. Okay, so just like here, when we counted the tours for each of the difficulties, we simply added the number 1 for each of the documents. And so here we do the same. All right, so let's again test this. And we're getting really close already to our end result. And indeed, here we go. So we have February with 1 tour, December with 1 tour, we have November, or actually September with 2 tours, and then we have 2 tours, and all of these on here. Actually, we have 3 tours in July. And so this is getting pretty close to our result. So that's absolutely fantastic. So this part here, which was, I think, the most difficult one, is already working. All right. Now, we actually want some more information, which is not only how many tours, but also which tours. So let's do that. And so if we want information about which tours, that should actually be an array, right? Because how else would we specify like 2 or 3 different tours in one field, right? And so basically we want to create an array. And we do that by using push. And then what we're going to push into that array as each document goes through this pipeline is simply the name of the document. Or actually the name field. Okay, so not the name of the document, but the name field. So in this case, the name of the tour. Okay, so let's test it. And bam, here we go. So we have also now the name of the tours in there. So fantastic. Let's see. Yeah, here we have all the 3. Next up, let's actually change the name of this field here. Okay, now, not really change, but we're simply going to add another field which will have the same value here. So that then later on, we can basically delete this ID. Okay, and so for that, we're going to use the next stage, which is called add field. So add field, and this one is pretty straightforward. It simply does what it says. So add field is used to add fields, and actually it is called add fields. And so now the name that we want to add, or the field, is called month, and it has the value of the field with the name ID. All right, so pretty straightforward, simply the name of the field and then the value, which as usual, we need to use the $sign. All right, just to test it again, indeed, now we have the month. Then next up, let's actually get rid of this, and so we use project. So I'm really trying to put as many stages in here as I can to show you really everything I can. So how does project work? Well, we simply give each of the field names a 0 or a 1. So let me show that to you. So we can say ID and set it to 0. And that will then make it so that the ID no longer shows up. If I put a 1 here, well, then it would actually show up. Okay? So this one I'm not going to test. Let me just add the next one, which is the sort one, which I believe I used it before, but still I want to sort it here by the number of tours. Okay, so right now it's not 100% useful. We are still missing because we should actually sort it really by the number of tour starts. So the name of the field is number of tour starts, and remember we had 1 before, which was for ascending, and -1 is for descending. And of course that's what we want. So starting with the highest number. So it should be 3 in our case. And yep, it is. So July is the busiest month with 3 tour starts: the forest hiker, the sea explorer, and the sports lover. Okay, so this is kind of done. Let me just show you one last stage here, which is not really helpful here, but I wanted to show it to you anyway. So we have the limit, and so this one is exactly the same as limit in the query. So basically it is going to allow us to only have 6 documents here. Okay, so basically 6 outputs. Okay, so let's test that. And so now indeed, we should only have 6. 1, 2, 3, 4, 5, and 6. All right. Again, not really useful because that's going to cut off the 6 least busiest month, which we don't want. So let's simply set it to 12 here, just so we can leave it here as a reference for you. All right. So one more time, but it should be working now, and the real business problem is now solved. And I know this is quite a lot of moving pieces that we have here, a lot of different stages, and so I know that it's a lot for you to take in at this moment. But don't worry, you don't have to know all of this stuff all at the same time. With practice, you will keep improving, and you will know when to use which of the tools that you have at your disposal. Just keep in mind that you can always read the documentation, which is kind of complete and a really great learning material besides this course. Okay, and that applies to all of the technologies that we're learning here. So I really encourage you to always also study the documentation. And I know that it can be really frightening to look at it, and without this course it would be a lot more difficult to learn from the documentation. But with this really good starting point that you get in these videos, it's then a lot easier for you to keep learning more and more using that documentation. Okay, so I wouldn't expect you to solve this challenge on your own, of course, which is why we basically did it together here, right? But I hope you had as much fun as I did, because again, I really love to solve this kind of problems. It's really fun, I think. But anyway, enough talking now. In the rest of the section, we will now talk about a couple of other features that we have available to us in Mongoose. So that should be pretty fun as well. So far in this section, we have talked about Mongoose models, CRUD operations with Mongoose, we did a lot of querying, and we learned about the aggregation pipeline. But now, for the next couple of videos, let's actually return to our data model and learn some super useful features that Mongoose offers us in order to model our data. And the first one we're going to talk about are virtual properties. And so let's open up our tool model here. All right. Now, virtual properties are basically fields that we can define on our schema, but that will not be persisted. So they will not be saved into the database in order to save us some space there. And most of the time, of course, we want to really save our data to the database, but virtual properties make a lot of sense for fields that can be derived from one another. For example, a conversion from miles to kilometers. It doesn't make sense to store these two fields in a database if we can easily convert one to the other, right? Okay, so let's now define a virtual property that contains the tour duration in weeks. And so that's a field, basically, that we can very easily convert from the duration that we already have in days, right? And so here is how it works. So we define that virtual properties on the tour schema, and so we say tour schema dot virtual, and then the name of the virtual property. So let's call it duration weeks. And then on there, we need to define the get method. And that's just because this virtual property here will basically be created each time that we get some data out of the database. And so this get function here is called a getter. All right. Now in here, we pass a function, and actually this callback function is going to be a real function, so not an arrow function. And I'm going to explain to you why in a second. Okay. Now, how do we then basically define the virtual property? Well, it's very simple. All we have to say is that we want to return this dot duration, in this case, divided by 7. Okay, so this is how we calculate the duration in weeks. So the duration in days divided by 7, because there are 7 days in the week. And so that's then the duration in weeks. For example, if a tour has 7 days, then it's of course going to be 1 week. Now, I used this regular function here because remember, an arrow function does not get its own this keyword. But in here, we actually need the this keyword because the this keyword in this case is going to be pointing to the current document. All right. And so usually when we want to use this, then we should always use a normal, a regular function. All right. So really everywhere in Mongoose, I'm going to always be using these regular functions that we're used to. Okay, so give it a save here. And that's actually it. That's how we define duration weeks, which is not going to be persisted in the database, but it's only going to be there as soon as we get the data. Now, right now, it's actually not going to be there yet because there's one piece missing here. So let me start by showing you that. So if we try to get all tours, you will see that duration weeks is nowhere to be found here. Okay, and that's because we need to explicitly define in our schema that we want the virtual properties in our output. Okay, and so remember how I said that here into this mongoose.schema, we can pass in not only the object with the schema definition itself, but also an object for the schema options. Okay, and so let's add that here at the end. So this first object here is the schema definition, and now second, an object for the options. And what we need to specify here is the toJSON property here. And what we say is then that each time that the data is actually outputted as JSON, we want virtuals to be true. So basically the virtuals to be part of the output. Okay, and now I'm duplicating this because we also want to say to object. So basically when the data gets outputted as an object. And so if we now go back here, we should then be able to see duration weeks. So let's wait for it. And indeed, here it is. So it's 5 days. And so that is 0.71 weeks. Here we have 7 days. And so that's 1 week. Okay, so that actually works. Great. Now, one thing that we need to keep in mind is that we cannot use this virtual property here in a query, okay? Because they're technically not part of the database. So we cannot say, for example, tour.find where duration weeks is equal to 1, okay? That's not going to work, again, because this property is not actually part of the database. Now, of course, we could also have done this conversion each time after we query the data, for example, like in a controller, but that would not be the best practice, simply because we want to try to keep business logic and application logic as much separated as possible. Remember? So that was that whole talk about fat models and thin controllers that we talked about before, which says that we should have models with as much business logic as we can offload to them and thin controllers with as little business logic as possible. Okay, and so virtual properties like this are actually a good example of how we can achieve that kind of architecture. All right, so knowing the duration in weeks is a business logic because it has to do with the business itself, not with stuff like requests or responses. And so we do the calculation right in the model where it belongs and not in the controller. All right. Just like Express, Mongoose also has the concept of middleware. And so let's now learn about the first type of middleware, which is document middleware. Now, just like with Express, we can use Mongoose middleware to make something happen between two events. For example, each time a new document is saved to the database, we can run a function between the save command is issued and the actual saving of the document, or also after the actual saving. And that's the reason why Mongoose middleware is also called pre and post hooks. So again, because we can define functions to run before or after a certain event, like saving a document to the database. Alright? So middleware is an absolutely fundamental concept in Mongoose, so just like in Express. And there are tons of possibilities and use cases for middleware, and we're going to be using middleware all the time in this project. So, there are 4 types of middleware in Mongoose: document, query, aggregate, and model middleware. And in this lecture, we're going to talk about document middleware, which is middleware that can act on the currently processed document. Okay, so just like the virtual properties, we define a middleware on the schema. So tour schema dot pre. Okay, and so this is for pre middleware, which again is going to run before an actual event. And that event in this case is the save event. And so this callback function that we're going to define here next, so function, so this function will be called before an actual document is saved to the database. Okay, so this is document middleware, and it runs, and let me write all of that here. So it runs before the save command and the .create command, all right? But not on insert many. So if we use this command here, so insert many, then that will actually not trigger the save middleware, all right? So always keep that in mind. It's very important to realize that only on save and on create, actually this middleware here is going to be executed, okay? And so let's start by doing a simple console.log. And what I'm going to log to the console is this, okay? And so in a save middleware, the this keyword here is going to point to the currently processed document. And that is the reason why it is called document middleware. Again, because in this function here, we have access to the document that is being processed. So in this case, the document that is being saved. Okay, and so let me just very quickly show that to you using this console.log. And so in order to now trigger this function, remember we need to run a save command or a create command. And so we now need to create a new tour using our API in order to then trigger this middleware. All right. So let's go here to Postman, and I'm going to start by saving these 2 new routes that we created in the previous lectures. So get monthly plan, and this one here is get tour stats. All right. So now I can close them and create new tour. And we specify the data here in the body. Now, not all of this stuff here is actually required. So let's take a look at what actually is required and get rid of the rest. So the image cover is required, the summary, of course the price, and so let's get rid of the stuff that we don't really need here, just to keep it at a minimum. So the ratings, quantity, average, so these are not necessary. So I'm just going to call this one here the test tour, just to keep it really simple here. Okay, now let's send this request. And indeed, it created the new document. And now let's take a look at our console and see that document here. And indeed, here it is. So let's increase this here a little bit. And so this is what our document is looking like right before it's saved into the database. Okay, and so here we have like ratings, average, and quantity, which are set by default, remember. So 4.5 and 0, and then like the created at timestamp, and you can even see the virtual property that we defined here. All right. So again, this is right before we actually save this data to the database. And so at this point of time, we can still act on the data before it is then saved to the database. And that is exactly what we're going to do now. All right. So down here in our middleware function. And what I want to do here is to create a slug for each of these documents. So remember how in the first section we created a slug for each of the products that we had in the store, right? And so a slug is basically just a string that we can put in the URL, usually based on some string like the name. So in this case, we're going to create a slug based here on the tour name. All right. So remember how for that we used the Slugify package. And so let's now go ahead and install that. All right. And while that's doing, let's go ahead and then require it here. So require Slugify. All right. Let's go back to our first window here actually. And now down here, we no longer want to log this to the console, but instead we can now say this. And remember, this is the currently processed document. So we can now define a new property on it. And that's exactly what I'm doing. So this.slug should be Slugify, and then just a string that we want to create a slug out of. And so that's going to be this.name. And then we also want to pass in the option that everything should be converted to lowercase. And so that's lower true. Okay. And now give it a save. And one thing that we didn't talk about yet is the next function. Okay. So just like in Express, we also have the next function in Mongoose middleware. Basically to call the next middleware in the stack, as we already know. Now in this case, we only have one middleware function, which is why we didn't run into any problems, even not calling next. But let's actually now do that. Okay, and so each middleware function in a pre-save middleware has access to next. Okay, so that's exactly the same as in Express. And so by the end of the middleware, we call next. And that will then call the next middleware in the stack. All right, so let's try this out again. And this is going to be called test tour number 2. All right, so very simple. Send this guy and let's wait for it. And now for some reason, it's not really here. Let's see if we got some error. And we actually did not. But the reason why it's not working is that right now we don't have any slug in our schema, right? And remember, this actually happened to us before when we only had a couple of fields in the schema. And when we then would define some fields that were not in the schema, then they were simply not persisted to the database. And the same thing is now happening here. So we defined the slug property, but it's not in our schema. And therefore, it was then not saved to the database. And so let's quickly fix that. Let's put it I don't know, it doesn't really matter. Can put it here right after the name. So the slug should simply be a string. Okay, and so that should fix it. So let's go back and create the test tour number 3. Because it cannot be the same, because remember, we cannot have tours with the same name. So do it again. And now indeed we have the slug property right here. And it is indeed based on the name, as you can see here. Great. So let's go back here. I'm going to reduce this a little bit. And so here we have the pre-document middleware. Let's now just very quickly experiment also with a post middleware. All right. So tour schema.post. And let's use save again. All right. And then the callback function, which in the case of post middleware has access not only to next, but also to the document that was just saved to the database. So let's call that one doc, and then next. All right. And so post middleware functions are executed after all the pre-middleware functions have completed. All right. So in here, we actually no longer have the this keyword, but instead we have the basically finished document here in doc. So let's just log that finished document to the console and then call next. Now in this case, again, we only have one post middleware, and so we wouldn't really need next, but it's a best practice to simply always include it. All right. Now another thing that I wanted to show you is that we can have, of course, multiple pre-middlewares or also post-middlewares for the same hook. All right. And hook is what we call this safe here, okay? So this middleware here is basically what we call a pre-safe hook, okay? So you will see that terminology all the time. So some call it middleware and some call it hooks, okay? And so this is going to be a pre-safe hook or pre-safe middleware, okay? So function, and this one has access to next. And so let's just log something to the console here, like will save document, and then next. And that, of course, should be next. All right. Just to see if we get some error, I'm going to omit the next here, okay, just to see what happens when we do not call it. All right. So I'm going to create a new tour, and by the end of this lecture, I'm going to delete all of them. But for now, we need them here. Okay, and so now you see that it's not really finishing. So we're stuck in that one middleware function that doesn't have the next call. All right, so basically we're stuck in here. So let's cancel the request and then get it back here and try that again. And so now it worked indeed. So our slug is here, right? And so let's take a look at our console. And so indeed, our second pre-middleware also run. So the one logging will save document, and then our post middleware then log to the console the final document. And so that should also already have the slug. And yeah, here it is. All right, and that's actually all I had to show you about document middleware. Now I'm just going to comment out these two here, okay, because I don't want to pollute my log here all the time with these console.logs, but I'm still keeping them here again as a reference. All right, so what I want you to remember from this lecture is that we can have middleware running before and after a certain event. And in the case of document middleware, that event is usually the save event, okay? And then in the middleware function itself, we have access to the this keyword, which is going to point at the currently being saved document, all right? And it's also very important to keep in mind that this save middleware only runs for the save and create Mongoose methods. It's not going to run, for example, for insert many, and also not for find one and update, or find by ID and update, which we already used before. So for example, somewhere here we have find by ID and update, but that is not going to trigger this save middleware. Okay, so that's very important to keep in mind, because actually a bit later in this project we will have to work around that limitation. All right, so this is document middleware to manipulate documents that are currently being saved. Next up, we're going to talk about query middleware. In this video, we're going to talk about the second type of Mongoose middleware, which is query middleware. And as the name says, query middleware allows us to run functions before or after a certain query is executed. And so let's now add a pre-find hook. So basically a middleware that is going to run before any find query is executed. So let's add another comment here. So this is query middleware. And of course, it works in a very similar way as before. So the tour schema and then pre, and in here we define the hook, which is going to be find. So function, and again, we have access to the next function. And actually, let's start by calling it here at the end so that we don't forget it. Okay, and so you see that it looks exactly like the other middleware, the other pre-hook. The only difference here is really this find hook, which will make this query middleware and not document middleware. All right, and so the big difference here is that the this keyword will now point at the current query and not at the current document, because we're not really processing any documents here. We're really going to be processing a query. Okay, and the use case that we're going to do here is this. So let's suppose that we can have secret tours in our database, like for tours that are only offered internally or for a very small, like VIP group of people, and that the public shouldn't know about. Now, since these tours are secret, we do not want the secret tours to ever appear in the result outputs, right? And so what we're going to do is to create a secret tour field and then query only for tours that are not secret. All right, so let's do that. Start by adding here, let's do it right at the end. Secret tour. So the type should be a Boolean. And I think this is the first time we're actually using a Boolean. So this should either be true or false. So if it's true, then it is a secret tour and we don't want it to show up. And by default, it is false. All right, and so basically, usually the tours are not secret. Okay, next up, let's actually go ahead and create a secret tour so that we can then test using it. Okay, so let's call this here the super secret tour. All of this doesn't matter. And let me just say that secret tour is indeed true. Okay, save it here. And where is that? Yeah, so secret tour is true. And let's now actually head over to Compass and delete all of these other tours that we had there. So let's reload this. And then down here, we should have, yeah, like this test tour here. You can delete that. Another test tour. So all this clutter here, basically, we want to get rid of it. We only keep the secret tour here so that we can now experiment with it. Okay, and you see here that secret tour is set to true, while the other ones, of course, do not have this attribute because by the time we created them, we didn't have the secret tour yet. Okay, so now, just before we start, back in Postman, let's confirm that indeed the last tour here, and actually it's not the last tour, so where is it? No, it's the first one. So here we have the super secret tour, of course, set to true. All right, so moving back now, let's now execute the query like we just said in the beginning. So again, keep in mind that this here is now a query object. All right, and so we can chain all of the methods that we have for queries. And so let's simply add a find method here, and then basically select all the documents where secret tour is not true. Okay, so secret tour, and then is not equal to true. And I'm doing it like this because remember, the other tours are not currently set to false. They do simply not have this attribute. All right, okay, so let's test it out now again. And so it should now be gone here. And indeed, it is no longer here. Okay, we have all the tours that are not secret, but not the secret tour. And I'm now seeing that we actually have secret tour set to false here, but that's really just a Mongoose thing. So let's take another look here at Compass and reload. And so you see that actually in the database, secret tour is not set to false. Mongoose is simply adding that because we have it in our schema as the default and it's not in the database. And so it's basically then putting it there anyway. So you see that we actually have 11 documents, but then here in Postman, we only get 10 results. And that is of course because our secret tour is basically filtered out. Okay, so let's try to understand again what really happens. So as soon as we hit this route here using the get method, let's see what happens. So what happens is that we create a query using tour.find. Okay, and then of course we chain all these methods to it as we talked about in one of the last lectures, and then by the end we then execute that query here by using await, right? Remember that? So this is where we execute the query. But before it actually is executed, then our pre-find middleware here is executed. Okay? And it is executed because it is find, just like we used here. Right? So we're creating a find query, and so therefore the find hook is then executed. Then in here, since it is query middleware, the this keyword points to the query. And so to that query, we can then chain yet another find method, right? And in there, we then filter out the secret tour using this filter object. Okay, so basically saying that we only want tours where the secret tour is not equal to true. And it would actually work the same if we simply set here false, but I find it cleaner like this. Okay, there is now just one thing that we need to fix, because right now this middleware is running for find, but not for find one. Okay, so let me show you the problem that we might get with that. So let's take the ID of the secret tour. So we have the secret tour here, and that's its ID. And so if we get tour, then that should give us the super secret tour here, right? And so you see that that filter that we just built in the middleware is not working for this command, okay? And that's because the handler function for this route, as you might remember, is using find by ID, which behind the scenes is find one. And so it's different from find, all right? So we need to specify the same middleware also for find one. Now there are two ways of doing that. And the first one would be simply to go ahead, copy this code, and then put find one here, right? But that's not really good. And so instead, we're going to use a regular expression. And that is quite easy. And let me actually just duplicate this here, comment this piece out. And then remember, a regular expression starts and ends with a slash. And then in here, what I want to say is that this middleware should be executed not only for find, but for all the commands that start with the name find. Okay? So find and find one, and also find one and delete, find one and update. And so all of these will now actually trigger this middleware function that we have here. All right? So no need for that. This regular expression here is way better. So again, this here simply means all the strings that start with find. And actually, since we're here, let me show you the Mongoose documentations again. So when we go here to middleware in these guides, you don't have an overview of all the middleware. For example, document middleware is the one that we talked about before, which runs, for example, on save. But in fact, document middleware can also run for stuff like remove, all right, or for validate. Okay, but I didn't talk about these because usually the one that we always use is just for save. All right. Now query middleware can run for all of these query functions. So find, as we just specified, and now with our regular expression, it's also going to run for find one and delete, find one and remove, and find one and update. Right? Anyway, moving back to Postman now, this should now have fixed this situation here. So when we now run this query, it should have no results. And indeed, it doesn't. Because remember, we were trying to get a secret tour. So the tour with this ID here is secret, but we never want the secret tours to show up in any query. And so that's why right now we get 0 results. Okay, so that works now. Don't save this. And now back to our code. Let's now actually also specify a post middleware for find. So tour schema, and then just like before, post. And then let's use our regular expression here again for anything starting with find. And then just the regular function. And then here in the post find middleware, we actually get access to all the documents that were returned from the query. So let's call that docs. All right. So remember that this middleware is going to run after the query has already executed. And so therefore it can have access to the documents that were returned. Again, because that query has actually already finished at this point. So let's log these documents to the console, so docs. But I also want to do something else here. So basically, let's create kind of a clock to measure how long it takes to execute the current query. All right, so how are we going to do that? Well, quite simple. We can simply set a property onto the this object, because this query object is really just a regular object. Of course, it has access to all these methods, such as find, but we can also use it to set any property that we want on it. So again, just a regular object. And so here we can say this.start should be the current date. Okay, and so this will set it as the current time in milliseconds. Okay, and so then here in the post middleware, so which is going to run after the query has executed, we can then subtract the current time minus the start time. So console.log query took, and now the current date minus this.start milliseconds. Okay, let's give it a save. And so let's now try to run a query and see our results. Okay, so here we get all our tours. Here we have the console. Let's actually clear that. There's a lot of stuff in there. Request again. And so here are all the results. So basically these are all the tours that were found. And so that's the result of console.log of the docs. So basically the documents that matched the query. But I'm now interested in this first console.log. And so here we see query took 120 milliseconds. And so that was basically the time that passed from the beginning, where we defined this, to after the query has executed at this point in time. All right, and that is all that I had to show you for now about query middleware. And just like before, of course, we're going to use this a lot throughout the course, because as I mentioned at the beginning, middleware is really a fundamental concept that's really important for a lot of stuff that we need in our applications. So we're almost done talking about middleware. Next up is the last one, which is aggregation middleware. So we learned about document and query middleware, and now the last middleware that we're going to talk about is aggregation middleware. And as you can probably guess, aggregation middleware allows us to add hooks before or after an aggregation happens. And so let's now actually continue with our previous example where we did hide the secret tours from the queries. Now in an aggregation, the secret tours are still being used, right? So let's quickly confirm that actually. For example, here in our get tour stats, so that's where we used the first aggregation. And so you see that we have 4 tours here, 4 in easy and 3 in medium. And so that makes a total of 11. But we already know that we actually only want 10 tours, right? So there are 10 tours that are not secret and then 1 that is secret. And so now we get all these 11 tours here. And so basically we also want to exclude the secret tour in the aggregation. So how could we do that? Well, let's take a look at where our aggregation is actually happening. So it's down here in get tour stats. And so what we could do is to, here in this match stage, simply exclude the secret tours that are true, right? So that would be quite easy to add here. But then we would have to add the same thing down here in the other aggregation that we have. And if we had even more aggregations, we would then have to add that in all of them. And that's of course not a good idea. Because for example, we could forget to do it, and it's also just repetitive code. And so let's simply exclude it right at the model level. All right. So let's add aggregation middleware here, starting with a comment. So aggregation middleware. And so just like before, we have tour schema dot pre. So we want this to happen before the aggregation is actually executed. And so here we use the aggregate hook. All right, and then our function, which again accepts the next function, so calling the next middleware. All right, so let's start by taking a look at this. So remember that up here in query middleware, the this object points to the current query. Then here in document middleware, the this object points to the current document. And so down here in aggregation middleware, this is going to point to the current aggregation object. Okay, and so let's take a look at that in the console. But before that, let me just remove this log here. All right, give it a save, run this aggregation here. And that's taking a lot of time. And so let's cancel it and go back. And that's probably because we're not calling next here. And so, like we already know, we get stuck in this middleware function. And so that's not good. So let's try that again now. Send. And yeah, so now we're back. And now let's take a look at the aggregation object. Okay, so there's a lot of stuff in here. So it's not really interesting here. And I cannot really find what I'm trying to show you here. And so let's simply add this dot pipeline, okay? Because what I really wanted to show you is just the pipeline object, okay? And actually it's pipeline like this. So it's actually a function, a method. So let's clear the console here. Try this again. And so here we get the aggregation pipeline. And so that's simply the array that we passed into the aggregate function before, right? So let's take a look. And so here we have that array, not this one, but this one. So we have the match, the group, and then the sort. And so if we take a look here at the console, we have indeed our match with the ratings average, we have group, and then sort. And so that is exactly the pipeline that we specified before. And so now, in order to filter out these secret tours, all we have to do is to add another match stage right at the beginning of this pipeline array, right? And so let's do just that. So let's do that here before this log. So this dot pipeline, and remember that this is an array. And how do we add an element at the beginning of an array? We use unshift. And so that is a standard JavaScript method for arrays. Okay, we have also shift to add at the end of the array, and unshift adds at the beginning of an array. And so again, what we want to add here now is to add just another stage. So very similar to what we have down here. So match, and then secret tour not equal to true. Give it a save. And so this piece of code here basically is exactly what we have up here, right? Basically removing from the output all the documents that have secret tour set to true, right? So if we give it a save now, then let's check this out. And remember, we have now 11 tours, 4, 4, and 3. So let's check the result afterwards. And so now, indeed, one of the difficult tours is gone. So we only now have 3 difficult tours, meaning that we're back to just having 10. Okay? And actually, we can confirm that our super secret tour was a difficult tour. All right? And so again, that is now gone. And so our results are now only about the regular non-secret tours. All right? And we can again take a look at our aggregation pipeline now. And here you see that now we have these 2 match stages. Okay? And as I mentioned before, it's no problem to repeat these stages. We can have as many match stages as we want. Okay, and that's it for aggregation middleware. I'm not going to include any post hook here for middleware. That's not really necessary. All right. And I'm also not going to talk about model middleware here because it's really not that important. All right. So middleware is some really cool and important stuff that we can add to our models. And there is indeed other cool stuff that we can do with models. For example, implementing instance methods, which are methods that will be available on every document after being queried. And that again can be quite handy. And we will do that later in the authentication section as well. Okay, so I'm going to leave that for a bit later. Now what we are going to do in this section just to finish is to actually add some validation. All right, and so in the next 2 videos we're going to talk about that. So Mongoose offers us developers very powerful ways of validating data that's coming into our model. And so in this video, we're going to learn all about data validation with Mongoose. Now, what exactly does validation actually mean? Well, validation is basically checking if the entered values are in the right format for each field in our document schema, and also that values have actually been entered for all of the required fields. Now, on the other hand, we also have sanitization, which is to ensure that the inputted data is basically clean, so that there is no malicious code being injected into our database or into the application itself. So in that step, we remove unwanted characters or even code from the input data. All right? And this is actually a crucial step, like a golden standard in backend development, to never ever accept input data coming from a user as it is. So we always need to sanitize that incoming data. But anyway, I will leave data sanitization for the security section of the course so that in this lecture, we can focus entirely on data validation. And we are doing this data validation right here on the model. And that again is because of the fat model and thin controller philosophy, which makes the model the perfect place to perform validation, right? And in fact, Mongoose already comes with a bunch of validation tools out of the box. And so let's now actually do some data validation here. And actually we already did. So when we used this require here, that is actually already a built-in data validator, all right? So you see that we use a validator like required right here in the schema type options. And required is actually available for all the data types. So not just strings, but really everything, numbers, booleans, dates, or really whatever type you're using. Then we also have unique here, but please note that this is actually technically not a validator. It will still produce an error when we have a duplicate name, but again, this is not really a validator, all right? But required is a validator, and so I'm going to show you now another one, which is specifically just for strings, which is called max length and also min length. So we have max length, and as the name says, we use this to specify the maximum length that a string can have. And if it's longer than that, well, then it's going to produce an error. All right? So let's do that just like we did before with required, where we specify an array and then set the value. So let's say we want 40 as the maximum string length, and then we add the error after that. So basically the error message that we get. So a tour name must have less or equal than 40 characters. Okay, so that is max length, and then we also have min length. All right, and so let's set that one to 10. So a tour name must have more or equal than 10 characters. Okay, and so just like this, we have these two validators that are actually only available on strings. Okay, and so let's now actually go ahead and try that. So I'm going to create a new tour here. And this is not a secret tour. But then here the rest actually does not matter. I will just call this one test tour. And let's see how many characters we have. So 4 plus 1 plus 4. So we only have 9 characters. And so we should now expect to actually get an error. So let's try that out. And indeed, a tour name must have more or equal than 10 characters. Great. But now what about updating tours? So let's get one of these here. So we have this test tour 2 here. So let's try to update this one. So we go to our update tour route. And then let's here change the name to test, send a request, and we get the same error. Now this only works because of a setting that we set way back when we implemented this updating handler. So let me quickly show that to you. In the tour controller, delete and update. And so it's because of this option here, run validators set to true, that the validators are run again. If I set it now to false, then Mongoose should happily accept this name, and indeed it does. All right. So let's set it back to something longer. It doesn't matter. Okay. And if I set it back to true, then it should not accept it. And indeed, we get our error back. All right. So just wanted to quickly show you the effect of that setting. All right. And so, yeah, these are now working. Let's try a couple of more validators here. For example, now on numbers. So let's go here to the ratings average, and we note that a rating must always be between 1 and 0. And we know that a rating must always be between 1 and 5. Okay? And so very similar to the min and max length, on numbers we simply have min and max. So the minimum that we want is 1. And then again our error message. So rating must be above 1.0, let's say. And then the max is 5. Must be below 5.0. Okay, and let's quickly test this one as well. So creating a new tour. Let's call it the test tour amazing because it has an average rating of 6. Okay, so let's see what happens then. And indeed, the rating must be below 5. Okay, and so that again is not going to work. And of course, it cannot be 0 either. So it must be above 1. Then of course, with 4, it is going to work. And indeed, here is our tour. Next up, I want to restrict this difficulty value here to only 3 difficulties. So easy, medium, and difficult. And if the user puts in something else, then it's not going to work. So let's try that out. So the validator that we use for that is called enum. Okay, and so here we can pass in an array of the values basically that are allowed. So we have easy, we have medium, and we have difficult. All right. Now we also want to specify our error message here, but right now that's not really possible, right? I mean, if we added another argument here, then that would not be for the error message. It would of course be for yet another possible value. Okay, and so the solution that we need to do here is to create yet another object here and then actually specify that these here are the values and then our message. All right, and so this is actually how it really works. This notation here is really just a shorthand for this complete object here. All right. So difficulty is either easy, medium, or difficult. Okay, and so that is a very nice, very handy validator that is automatically available on all strings. Okay, so don't try to use this one here on numbers, for example. This is only for strings. And by the way, this min and max here is actually not only for numbers, but it's also going to work with dates. All right. Anyway, let's now finally test this out as well. So we need to change the name. And then here, let's put something else. All right. And so indeed, we get our error. If we now put easy, then it works. Okay. And that's actually all I wanted to show you here in this lecture. But there are actually a bunch of other validators. For example, on strings, you have a match validator in order to check if the input matches a given regular expression. But I believe that these ones that I just showed you here are the most important built-in validators. And for a complete list of all of them, of course, you can always check out the documentation. Now we can also specify our own validators, and so that is exactly what we will do right in the next video. Next up, let's talk about custom validators. So sometimes the built-in validators are simply not enough, and in that case, we can also build our own custom validators. And a validator is actually really just a simple function which should return either true or false. And if it returns false, then it means there is an error. And on the other hand, when we return true, then the validation is correct and the input can be accepted. Okay, so let's now build a simple custom validator here. And what I want to validate is if the price discount is actually lower than the price itself. Okay, so that's something that we cannot do using the built-in validators, and so we're simply gonna build our own. All right, so we need to now specify here an object for the schema type options. All right. So the type is number, and then to specify our validator, we use the validate property. Okay, so validate, and then, as I said, a simple callback function. Okay, and again, not an arrow function, but a real function, because in this function, we're gonna have access to the this variable, which will point to the current document. Okay, now if you didn't need the this variable, then you could, of course, just use an arrow function. Okay, so we have a callback function, and that callback function actually has access to the value that was inputted. So in this case, the price discount that the user specified. So that's what I call the value, so val for short. And so remember that we need to return either true or false from this validator. Okay, so when do we want to return false and when do we want to return true? Well, we want an error when the price discount is greater or equal than the price. Okay, and so basically what we want to return here is the test of testing if the value is less than this dot price. All right, so let's say that the price discount is 100 and that the real price is 200. So 100 is less than 200, true, and so we have no error. And that makes sense because that's exactly what we want. The price discount should always be lower. On the other hand, if the discount is 250, then this turns out to be false. And then false, remember, will trigger a validation error. All right, so let's now test that out actually. So price and price discount. And let's use the values that we used before. And I also need to change the name here. Okay, so right now our discount is greater than the price. And so we should get our error. Okay, and indeed, we have a validation error. So failed for path price discount. Now we do not have any custom message here. And so let's quickly fix that. All right, and the way we do that is in a very similar way as we did with the enum. Okay, so we need to actually specify another object and then set the message property. Okay, so validate should be an object, And then we have our message in there. And this function here will live in a property called validator. Okay, and our message here will be discount price should be below the regular price. All right, here we need a comma. And so now we're good. And actually one very nice trick is that this message here also has access to the value. And this works in kind of a weird way. And this really is internal to Mongoose. So this has nothing to do with JavaScript. So I can simply use the curly braces here and then value. Okay, so this piece here will get access to the value that was inputted. So it has the exact same value as this val variable. All right. So let's test that again. And now indeed we get our message and even access to the 250 price that we specified here. Now let's change it to 100, and so now it should work. And yeah, it does. So great. Now there is one very important caveat that we need to notice here. And that is that inside a validator function, the this keyword is only going to point to the current document when we are creating a new document. Okay, so this function here is not going to work on update. Okay, and so that's very important to note. So you see that in Mongoose there are a couple of caveats that you really need to be aware of when working with it. Okay, and I learned all of these by experience, and so that's why now I'm able to tell them to you. So I ran into an error once with this one, and so from that time on, I know that I can only use this kind of validator with a this keyword in there when I'm actually creating new documents. So let me write that down here for you. All right. So I hope that you're kind of taking note of all of these very important small pieces of information that are very important. Okay. The same thing down here. Remember that where I told you that this document middleware only really runs for save and create, but not for update. Okay. And that's one of these other things that are really important to never forget. Okay. Now in this specific case here, there are actually ways around fixing this, but they're very complicated and not really worth pursuing, all right? And we could, of course, also write validator functions that do not rely on a this variable. So in this case, we only need it because we're comparing one value with the value of another field, all right? Anyway, this is a custom validator that we can use in Mongoose and that we did actually write ourselves. But also, there are a couple of libraries on NPM for data validation that we can simply plug in here as custom validators that we do not have to write ourselves. All right, and the most popular library is called Validator. And so let's actually take a look at that one. So Validator, and then I'm searching for GitHub because usually all of these libraries are always on GitHub. And the documentation is also going to be there. And so here you see that validator is a library of string validators and sanitizers. All right. You also see that it's quite popular with 30,000 starts. And so yeah, that's very good. All right. So we also see this library validates and sanitizes only strings. All right. So here is then all of the stuff, how we install it and how we use it. But that's kind of simple, we already know that. Well, what I want to show you is the list of all the available validators. So for example, we have isAlpha, which is going to check if the string contains only letters. We have alphanumeric, so only letters and numbers. And we really have a lot of stuff here. So check if a string is Boolean, or check if the string is a credit card, so a valid credit card number, or if it's a currency, or you see really all kinds of different tests. For example, an ISBN, so for checking book numbers, to test if it's an integer, or if the string is lowercase. And so you see, whenever you need some data validation, you can grab one of these libraries and simply plug them into your Mongoose validators. Okay? Now, many of the things that are here are actually already built into Mongoose, and so we don't need all of them. Okay? But there is one very specific, which I want to use, which is alpha. So I want to check if the tour name only contains letters. All right? And so for that, I can use this function from the validator library. So let's go back and start by installing npm I validator. All right. So that was successful. Then I need to import it here. And so now we're good to go to actually use it here. So I'm going to use it here. And again, I use the validate property. And now all I need to do is to really plug in the function here. Okay, and in validator, it works like this, where validator is an object, and on there we have then all these methods. So validator is alpha. So that's the one that we just choose from the documentation. All right, and that's actually it. So we don't call it here. We basically just specify that this is a function that should be used. All right. So just like our own one, like our own validator, we didn't call it. We simply put this callback function here that is going to be called as soon as the data should be validated. All right, and so here it's the same. Now, if we want to specify an error message, it works just like up here. So we can specify an array and then the error message after the callback function. And we could have done that down here. So here we did it differently. Here we then created this new object with validator in there and then message, but we could have done it with an array as well, but that would have looked weird, right? But up here, since the function is so small, so this is so small, we can simply put it here and then as a second argument in the array, add the error message. So tour name must only contain characters. Great, check that out. Back in Postman here, let's get rid of our price discount. And let's add some number here. And so that should then fail the test. And indeed, the name must only contain characters. So let's get rid of that. We can also not use this name. We already used it before. So let's simply write out 2 here with characters. And we still get this error here. And well, that's probably because of the spaces. So let's just get rid of the spaces, which of course is not going to be real useful. And indeed, now it works. So the problem was the spaces, but obviously we want to keep the spaces here. All right. And so in fact, this validation here is not really useful. And so I will get rid of it. Okay. So consider that this here was only to demonstrate that we can use an external library like this to perform validation. And actually we will still use this library a bit later when we check if the user email is actually valid. So that's another nice function that is included in this library. All right. So again, this is how it works. Not really useful in this case. So if we really wanted to test if the string only contains letters and spaces, it would probably be simpler to simply use a regular expression to test for that kind of pattern. All right, but I'm not going to do that here because this lecture was more about these custom validators. Anyway, with this lecture, we are now ready with the introduction to Mongoose. All right. Now, as you can imagine, there is of course still a lot to learn about Mongoose. And in fact, we have an advanced Mongoose section a bit later in the course. And of course, also in the other sections, you will keep learning more and more about how to use Mongoose in a real professional way. But anyway, you have already learned so much up until this point. So huge congratulations for making it this far. And it's great to see that you're still with me here. So great job, and I hope to see you soon.